Hello guys, welcome back to Core Reader channel. And in this video, we are going to launch a new course, Master Solidity. This course will be a full-fledged course to master the Solidity programming language. And in this video, I'm going to give you an overview of what are the things that we are going to cover in this Solidity course, or I will say Master Solidity course. Now, before talking about the course overview part, let me tell you why this course is different from any other course that you might have seen on YouTube or on any other platform. Like, see, most of the Solidity course that you see on any other platform or YouTube, most of them only cover the syntax part of Solidity. They are going to tell you how to declare a variable, they are going to tell you how to write a loop, they are going to tell you, how to write a contract and everything, but they are not going to discuss the concept part behind each syntax, which is very necessary in case of Solidity. And in this course, I'm going to talk about the concept part of each and every syntax that I'm going to introduce in this particular course. So if I'm talking about variables, then I'm going to talk about state variables. What is local variables? When to use state variables, when not to use state variables. How to write mappings, how mappings are different from arrays. So I'm going to cover the concept part of each and everything that I'm going to talk about in this particular course. Then in this course, I'm going to introduce 3 Solidity projects. Yes, I'm going to cover 3 Solidity projects, and these will be major projects, guys. Let me tell you, these will be major projects. All these projects, like the first project will start from the beginner level, then the intermediate level, and then the advanced level. So all these 3 things will be the part of this Master Solidity course, which make this course different from any other course that is available on YouTube or any other platform. Now let me give you an overview of this course. So what are the things that we are going to see in this particular course? We are going to start with what is Solidity. You have to understand Solidity as a programming language, what it is, how it is different from any other programming language. So we will start with this. Then we are going to talk about the Solidity compilation process, which is very important thing. Most of the Solidity developers do not have an idea about this, and this is a very important concept. So we will talk about this Solidity compilation process. Then we will talk about state and local variables. So you will understand all these things once we will start with this course, so just don't worry. Then we are going to talk about the functions. We are going to talk about visibility specifiers. So there are a lot of visibility specifiers in Solidity. We have public, private, internal, external. So we will talk about all these things in great detail in this course. Then we are going to talk about the basic data types like integers, bool, address. So we will cover all the basic data types that Solidity provides us. Then we are going to talk about loops and then conditionals, like how to write a else statement, what is required, what is modifier. So we are going to talk about all these things in this conditional section. Then we are going to talk about arrays, the different type of arrays, what is a fixed size array, what is a dynamic size array. So we are going to talk about all these things. Then we are going to talk about mappings, how mappings are different from arrays, how to create a basic mapping, how to create a mapping with struct, how to create mapping with arrays, how to create nested mapping. So we will cover each and every aspect of mapping data type, which is a very essential data types in Solidity programming language. And after that, we are going to talk about structures and enums, a very important thing, because most of the time you're going to use structures and enums in your Solidity projects. So we will see that. Then we are going to talk about global variables. So we have a lot of global variables provided by Solidity, like msg.sender, msg.value. So we will see all these things in this global variables section. And definitely this is just an overview, guys. Do not think that this is just, I'm going to cover only 16 videos. No, this is just an overview of this course. There will be a lot more than 16 videos. Okay, so just don't worry about it. Now let me talk about the projects that we are going to cover in this particular course. So we are going to cover 3 projects, as I said, right, in this particular course. So we will start with Lottery Smart Contract, which will be a beginner level project for Solidity developers. So you will understand, how to write a Solidity smart contract via this lottery project. Then we are going to talk about Crowdfunding Project. This will be an intermediate level project where you will see how crowdfunding is done using Solidity programming language. And if you do not know all these terms, just don't worry. We are going to talk about all these terms in great detail in the upcoming videos. Then we are going to create the third and the last smart contract, which will be an advanced level project that will be event organization project. It will be a great project, and you can add all these 3 projects in your resume to impress your employer. So as I said, we are going to cover lottery smart contract, crowdfunding smart contract, and event organization smart contract. So that whatever concept you are studying, in the Solidity course, you are going to apply all those concepts in these 3 major projects. Now, is there any prerequisite to this course? The only prerequisite to this course is, first thing, that you should have idea about the blockchain fundamentals. And good news is that I have already created a 6 hours blockchain fundamental course. You can watch that course. I will share the link in the description as well as in the I button. You can watch that course and then you can switch to this particular course. And another prerequisite to this course will be that you should have knowledge of at least one programming language. That programming language can be, C, C++, Java, Python, JavaScript, any programming language. You should just have knowledge of at least one programming language. Now, when I'm saying knowledge of at least one programming language, I'm not saying that you need to be an expert in that programming language. What I'm trying to say is that you should know the fundamentals of that programming language, like how to, create a loop, or what is a loop actually, or what is a variable, what is a data type. Because I'm not going to talk about what is a data type or what is a variable. Definitely, I'm going to talk about how to create a data type, or how to create a loop, everything in Solidity. But I'm not going to tell these basic terminologies like what is a variable, what is a data type, all these things. So you should have knowledge of at least one programming language before taking this course. These are the only prerequisite of taking this course. Now in this video, we are going to talk about Solidity. Since this entire course is all about Solidity, so it is very essential to understand what is Solidity, right? So what is Solidity? Solidity is an object-oriented programming language for implementing smart contracts for the Ethereum blockchain. Now, for people who are from object-oriented background, means who have studied about Java or C++ kind of programming language, they will be knowing about object-oriented. But let me tell you what is object-oriented programming language. Object-oriented programming language are those programming languages which deals with classes and objects. And we will talk about this in depth in our upcoming videos. For now, just remember this point that Solidity is an object-oriented programming language, okay? And it is used for implementing smart contracts. Means with the help of Solidity, you can create smart contracts, and these smart contracts will be then deployed on the Ethereum blockchain. And as we have discussed about smart contracts are simply program that you write on the Ethereum blockchain, right? Or any other blockchain as well. But since we are talking about Solidity and since we are talking about Ethereum blockchain, so we can say that, okay, smart contracts are programs that are used to write on the Ethereum blockchain. Second thing, that Solidity is a high-level, statically typed programming language. Now, what do I mean by high level? High level means that it is a programming language which can be well understood by humans. Means this programming language is not written in your binary number format or in your assembly language format, which are example of low level programming language, right? Because those programming language can be easily understood by our computers, but we cannot understand them easily, right? So those are low level languages, while Solidity is a high level language. It is statically typed. So there are basically 2 kind of programming languages. First is statically typed and another one is dynamically typed. So if you have studied C, C++, these are example of statically typed programming language as well as Solidity as well, right? So statically typed programming languages are those programming languages in which we need to tell the data type of the variable that we are declaring at compile time. Okay, so you have to tell about the data type that you are going to use in your program before compiling it. While if we talk about dynamically typed programming language like Python, in that case, you do not need to tell the data type of the variable that you are going to use. So that's an example of dynamically typed programming language. Like if you have studied Python, you directly write a equal to 2 and your interpreter then detects that, okay, this is a integer type value or it is a floating type value. Your interpreter detects it once you run that programming language. While in case of statically typed, it is not the case, okay? It is case sensitive. Now, what do I mean by case sensitive? So if we talk about Solidity, let's say if we are declaring some variables. So let's say I declared one variable by CAR, one by capital C, then small r and A, and one by, let's say, all small letters.
So here you can see that we have written car in three different ways, right? And for Solidity, all these three cars written in different format, one which is fully capital, one which is, first letter is capital and the rest are, not capital. Then we have all the small letters. So for Solidity, all these three are different kind of variables. So it is case sensitive. So it differentiate between your small letters and capital letters. Okay. Now, Solidity, you can create smart contracts such as voting, crowdfunding, blind auction, multi-signature wallets. So, Solidity provides you the facility that you can create a different kind of smart contracts. And in this course as well, we are going to create a lot of different projects with the help of Solidity as a programming language. Now, last but not the least, that you should follow established development best practices when writing your smart contracts. Why? Because as we all know, that blockchain is immutable, right? So once you will write something on the blockchain, let's say if you are deploying your smart contract on the blockchain, now you are not in any position to change your smart contract. So once your smart contract is deployed on the blockchain, you cannot change it at any cost. So you might be thinking, okay, what if there are some bugs or what if there are some issues? You cannot do anything. Once it is deployed, it is deployed. You cannot change it. Definitely, there are different kind of methods with the help of which you can upgrade your smart contract, but that's a different story that is out of the scope of this course. But remember this point: once you will deploy your smart contract, it cannot be changed. That's the golden rule, or I will say that's a warning, or that's a caution that you should remember, that you have to be very much careful whenever you are creating your smart contracts. Okay, so I hope you enjoyed this video, you understood what is Solidity. Meet you soon in the next video. Till then, bye bye. Hi, now in this video we are going to see how we can run our Solidity programs. So to run our Solidity programs, we are going to use this IDE by the name of Remix. So on Google, just search for Remix IDE and then click on this first link, okay, where it is written https remix-project.org. Just click on this link. Now you can see that this is a very beautiful website, I think. And then when you will scroll down a little bit, you will have multiple options here. So for now, in the starting, we are going to use Remix ID on our browser. So we are not going to install this on our desktop because we do not require it. So we will simply click on this button. So once you will click on this button, you will see that Remix ID will open in your browser. So no installation, nothing, we are good to go. Isn't it good? We do not have to install anything. So now, let me give you an overview of this Remix ID, how we are going to use it, how we are going to create our contracts and everything from scratch. Now on your screen, you must be seeing this home. Just close it for now. Now on your left hand side, you must be seeing this panel. Okay. Now in this panel, you can see there are multiple folders, multiple buttons, and I'm going to explain you each of these things. So in this, first of all, let's talk about all these folders. So in these four folders, or I will say two folders, and this remix, this readme.txt, we do not require any of these three things. So just don't worry about these two folders as well as this file. Okay, so we need to concern about only this folder by the name of contracts, where we are going to write our contracts. So just click on this folder. So once you will click on this folder, you will see that there are multiple Solidity smart contracts which are already created for you by the Remix ID. So let's see one of those contracts. I'm clicking on this storage.sol. So you can see that there is your Solidity smart contract. At this point of time, this program might be looking alien to you, right? But don't worry, I will explain you each and everything. So you can see that there are multiple contracts created by your Remix ID. But we do not need to worry about all these contracts. What we are going to do is we are going to create our own contract. And for that, I will click on this button, as you can see here. Okay. And when you will hover over it, you will see an option, create new file. Just click on this create new file button. Once you will click this create new file button, okay, now the problem is it is creating one file, but it is creating at this, at the not in your contracts folder, but in this workspace, but we do not want to create our contract in this workspace. We want to create our contract in this contracts folder. So first select this contracts folder, then click on this create new file. Now once you will click on this create new file, you have to give a name to your Solidity contract. So in this example, let me give it a name. Let's say demo. Okay. And for your Solidity programs, remember guys, for your Solidity programs, you will always end your file with .sol. .sol is an extension for your Solidity programs. Like in C, you have .c, in Python, you have .py. Like that only, Solidity has this extension .sol. Now enter. Now once you will enter, you will see that your smart contract is opened here, and you can see that it is open because we are on this tab. You can close all these remaining tabs because we do not require them as for now. Now this will be your editor. This will be the place where you will be writing your smart contract. Okay. Now before creating our smart contract, let me tell you all these different buttons as well. Right off your create new file button, you will see one more button by the name of create new folder, with the help of which you can create folders in your let's say in your this workspace. Okay, if you want to create any other folder by the name of, let's say, project, or let's say school, so you can create folder with the help of this button. Then you have an option of GitHub, but currently we are not going to use it, so just don't worry about it. Then this is an option to load one of your local file. Let's say you have created one smart contract as a text format in your notepad and you want to upload it on your remix id, then you will select this button. But again, we are not going to do that, so don't worry about it for now. Then on top of it, you will see that we have this default workspace. Now this default workspace is the workspace where all your folders and all your contracts are present. Okay, so let's say you are creating one project for your school and one project for your college, then you can create different workspaces. So you have to just click on this plus button. Now you will see that, okay, this is default, so you have to just select this default, and then you have to give the name to your workspace. Let's say I want to create for my college, so I will just enter college. I will click on OK. So you will see that now we are in a different workspace because you can clearly see that our demo.sol contract is not present here, right? So this is a different workspace, and I hope you have worked in VS Code or something like that. If you haven't, don't worry, we will work. But this is just like going to a different workspace. If you again go back to your original workspace, you have to again click on this workspace area, and then you have to go to your default workspace. So again, we are back. We can again go to contracts, and then we can go to our demo.sol. So again, as I said, that this will be an area where we are going to write our smart contract. Now, before you write your code, you have to mention two very important things whenever you are writing your smart contract. The first thing is SPDX license number. We will talk about SPDX license number in our upcoming videos. For now, what we are going to do is we are simply going to copy this from here. Okay, just copy it for now. I will explain you what is this in our upcoming video, in our upcoming slide. Then another thing that we need to have is this Pragma. Now, what is this? I will explain you again in the upcoming video. For now, just copy it down. So these are the two compulsory lines that you will be writing whenever you are creating your smart contract. Okay, first the SPDX license number, and then this line Pragma Solidity greater than equal to 0.7.0 less than 0.9.0. Okay, now once you will do that, now you will be writing your smart contract. Now before moving further, let me tell you one thing. Let me be very clear here that do not worry about the syntaxes that I'm going to use, because we are going to talk about each and every syntax. We are going to talk about each and every concept in our upcoming videos. This is just a sample Solidity program just to tell you how we actually write our smart contract. Okay, so this is a very simple sample smart contract just to make you familiar like how you actually write Solidity code. Okay, so don't worry about the syntax or the keywords that I'm going to use. So first thing what we have to mention is the contract name. So I will write contract. This is the keyword that is provided by Solidity. So first you have to write this, then your contract name. So now we can name our smart contract anything. Like I can name it as ABC, or I can name it as, XYZ. Whatever name I want, I can give it to my contract. Okay. So let me give it this name, one of the name as demo, because if you will see, we have created this file, this smart contract by demo.sol, and this is a good practice. Like whatever name you are giving to your file, you should give to your contract. Why I'm saying this? Because this will make, let's say, if you are creating various smart contract, in that case, it will be very easy to find which smart contract is present where, right? So that's why I'm saying this. So like this. Okay. Now within this curly braces, we write our code. As we all know, the tradition of any programming language, whenever we start with any programming language, we always start with hello world, right? So in the same way, we are going to start with hello world in Solidity. And how we are going to write hello world in Solidity? Simply, we have to first write string. So this is the data type provided by Solidity. String is a data type provided by Solidity. Then we have to mention this keyword public. Okay, we will talk about it, so don't worry. And then the variable name, so let's say str. Okay, and in this variable name we will assign hello world, like this. Okay, so remember to put semicolon at the end of your each statement in Solidity, because Solidity is just like your C programming language, C plus programming language, or Java programming language, where you have to write semicolon at the end of your each statement. Okay, so now our work is done. Yes, our work is done. We do not need to do anything. We have written hello world in our Solidity programming language. You must be thinking, okay, so we are not going to write any code like function or something. We just need to declare one variable. Yes, that's it. Once you will do this, your work is done. Now, once we will do this, we have to simply compile our smart contract. And to compile our smart contract, we will again go to this left side, and you have to go to this symbol. Okay, this symbol that you can see on your screen, just click on this. Now once you will click on this, you will see that you have a lot of information, right? But you do not have to worry about any of these information. You have to just change your compiler version to the latest version. Okay, so in this you can see that we have a lot of compiler versions, and we will select the latest one, that is 0.8.17. Okay, so select this. Now once you will select this, it will take some time to respond because it will be adjusting this compiler. So you can see that this compiler button is still not available for use. Now it is available. Now once it is available, you have to simply click on this compile button, and it will compile your smart contract. So I will click on compile. Your smart contract is compiled. And how I can say this? Because of this green tick that you are seeing on this button, right? So once you will compile your smart contract, you will see this green tick on this button. Okay. Now, once you will compile your smart contract, it's time to deploy your smart contract. And how we can deploy our smart contract? We have to simply go on this button, which is just below your compile button. Just click on this. You will see a lot of information on this side, but you do not have to worry about any of these things for now. You have to just see the environment tab. So this is your environment tab. This actually tells us where we are actually deploying our smart contract. So in this case, if you will see, by default, it is selected Remix VM London. So when you will click on this deploy button, this smart contract will get deployed on this Remix VM London. And what is this Remix VM London? We will talk about this when we will talk about our contract deployment environment. So I will talk about this there. Okay. For now, let us click on this deploy button. So once we will click on this deploy button, our smart contract will get deployed. And how I can say this? Because once you will click on deploy, here you will see the information that, okay, your transaction is successful because of this green tick. Okay. So as soon as I will click on deploy, you will see that this green tick will appear. So let me move it ahead. Let me again deploy our smart contract. Deploy, you can again see that a green tick appears here, means we have deployed our smart contract. So just scroll down. So here you will see that you have two smart contracts because we have deployed our smart contract 2 times, right? So we can delete one of them. Let's say I want to delete this. So I will delete it. I will then select this. Now, once you will select this, you will see that there is your variable str. Here you can see that, right? We have declared our variable by the name str, and the same variable is present here, is in the form of a button. Now, once we will click on this str button, you will see it will return hello world. So hooray, we have completed our first task of printing hello world in Solidity. Yes, there is no print statement or any such thing in Solidity. So we are going to use this shortcut form in order to print hello world in Solidity. So in this video, we learned various new things, right? We learned how to create our smart contract, how to compile our smart contract, how to deploy our smart contract, and so many other things. In the next video, we will talk about the compilation process of Solidity, which is very important to understand. So meet you soon in the next video. Till then, bye bye. I hope so. In the previous video, we have seen how we can use Remix ID in order to compile and deploy our smart contract, right? And now in this video, we are going to see what actually happens whenever we compile our smart contract. So let's say you have created this source.sol file. So this is your smart contract. And now you have given this smart contract to the Solidity compiler. So in the previous video, as we have seen that we were using Remix ID, right? Now behind the scene, Remix ID is actually using Solc. Solc is the Solidity compiler. Okay, so remember this, that Remix ID is just an interface, but behind the scene, Remix ID is actually using Solc as a compiler. Okay. Now, when you give this source.sol file to this Solidity compiler, it divides the file into two parts. Or I will say, after compilation, it generates two parts. First one is your ABI, and second one is your bytecode. Now, what is an ABI? ABI is known as Application Binary Interface. And what is this application binary interface? This application binary interface acts as a bridge between your Solidity smart contract and your external world. Now, let's say if you are creating a decentralized application, okay? So in order to create your decentralized application, you are going to have a front-end technology, right? And we will talk about all this when we will talk about decentralized application in detail. So don't worry about it. But for now, just let me give you a hint about it. So in this decentralized application, you will have a front-end technology, right? Say you are using React.js. Now this React.js application wants to communicate with your Solidity smart contract. Now in order to do that, this React.js code, this React.js technology will be using ABI in order to communicate to the Solidity smart contract. So let's say React.js fronting technology wants to call some function of this smart contract that we have created, or let's say access some variables of this smart contract that we have created in this source.sol file, then we will be needing the ABI of this smart contract. And I will show you how actually this ABI looks like in some time. And another part we have is the bytecode. Now this bytecode is the code that actually get deployed on the Ethereum blockchain. So your entire source.sol file code is not getting deployed on the Ethereum blockchain, but only the bytecode of this smart contract gets deployed on the Ethereum blockchain. Now, what is this bytecode all about? This bytecode actually consists of instructions related to your smart contract. Let me show you how this ABI and bytecode looks like so that you can better understand it. So this is a very simple smart contract that you are seeing on your screen. Again, do not worry about the syntax and everything. I'm going to talk about all these things in great detail in the upcoming course. For now, let us focus on the concept part only. So we will go to our compile section as we have discussed in the previous video. This is our compile part, right? This is our compile button. So we will go to this part. Again, if you want to switch to the latest version, just switch to the latest version. We will click on this compile button. Now see very carefully, as soon as I will click on this compile button, you will see that two files will get generated in this bottom. In this left bottom, you will see that two files will get created. So let me click on compile.
So as soon as I clicked on compile, you can clearly see that we have two code generated after this compilation process. One is the ABI and second one is the bytecode. Let me show you how this ABI actually looks like. So I'm using this notepad that is available online. You can use on your computer as well. Just copy this code or it will be available in your Solidity smart contract in this storage.sol. Okay, so you can directly compile this code. Once you will compile this code, you will see that you will have this ABI. Just copy it and paste it to your notepad. Now, once you will paste it to your notepad, you will see a structure something like this. Okay. So now in this ABI, you can clearly see that what are the functions you have created in your smart contract, what are the variables that you have in your smart contract. Like for example, if you will go back, you will see that this smart contract consists of two functions, right? As you can clearly see that function 1 is a store and function 2 is retrieve. So if you will see in the ABI of this code, you will see that you have this function retrieve here. So name retrieve, and this is the type of function. So this is a function type. And another function that is a store, and this is also a function that you have created in your smart contract. So all the information related to your smart contract about the variables, about the functions are actually stored in the ABI of your smart contract. So that when an external technology, let's say React.js or any other smart contract, want to call any of the functions given in your smart contract, it can directly access it using the ABI of your smart contract. Okay. And then let me show you the bytecode. So I am copying this bytecode. Let me paste this bytecode here. So this is your bytecode. Okay. So this thing that you're seeing, right? This is your bytecode. And this is in JSON format. This is the key. Okay. So this is the key and this is the value. Okay. And another thing that you can clearly see on your screen is the opcodes. You remember we have discussed about this concept in the Ethereum gas limit video, right? Where we talked about that Ethereum provides you with a list of opcodes. So this bytecode is actually getting converted into this opcodes. And as we have discussed about opcodes in the Ethereum video, that opcodes are nothing but these are instructions. Okay, so we are providing some instruction to our smart contract that okay, you have to do this, then do this and do this. Okay, so these are all those instructions that we are providing. So when are converting these functions, this is a high level program. This high level program is getting converted to this low level program kind of a thing. You can understand like this. Okay, so this is what actually happens whenever we compile our smart contract. Let's see some of the important points related to the Solidity compilation. Contract bytecode is public in readable form. So whenever you are deploying your smart contract, bytecode of your smart contract is actually getting deployed on the blockchain. Since it is getting deployed on the blockchain and blockchain is in public form, so it is available for the people to read. Okay, so whenever you are going to deploy your smart contract, your bytecode is getting actually deployed on the blockchain and your bytecode is actually in public in readable form. Second thing, contract doesn't have to be public. So in our example, when we created source.sol and when we compiled it, right? So this source.sol need not to be public. You can keep it private. It is not a necessity or it is not some rule that you need to make your contract public so that anybody can read from your smart contract. Okay. Third thing, bytecode is immutable. Now this is something which actually makes your smart contract immutable. Since bytecode cannot be changed, you cannot change your smart contract. Fourth, as I discussed, that ABI act as a bridge between applications when I'm saying applications, so any external technology that we are using, and a smart contract. So this applications can easily communicate with our smart contract. And fourth, ABI and bytecode cannot be generated without source code. So as we have seen, when we have given this source.sol file to the Solidity compiler, it generates two files, ABI and bytecode. So you cannot go reverse. You cannot generate your smart contract by having your ABI and bytecode. So it is a non-reversible process kind of a thing. Okay. So I hope you enjoyed this video. meet you soon in the next video. Now, in this video, we are going to talk about SPDX license number, Pragma Solidity, and contract development environment. So, if you remember from our Solidity sample program video, where we have created a sample program in Solidity, in that video, I told you one thing, right? Whenever you are creating your smart contract, you have to first write this line, that is the SPDX license number, and then this Pragma Solidity line. Now, what is this SPDX license number? Let us first answer this. Or let me first answer this. So, this SPDX license number is the license number that you give to your contract. So, if you remember from our previous video about our Solidity compilation process, I told you that your smart contract doesn't need to be public. Means whenever you are deploying your smart contract, your bytecode is getting deployed on the blockchain, and this is smart contract, the source code, it does not need to be public, right? Why? Because let's say if you will make your contract public, chances are high that someone will copy your contract. So let's say as a company, you have worked hard in order to create this is smart contract where thousands of developers have worked for your smart contract, just an example, and now someone is copying your smart contract. This will not look good, right? So chances are high that you think, okay, I do not want to make my smart contract public in nature. But when we talk about blockchain is all about transparency. So it is a good practice. It is a good practice to make your smart contract public, even though it is not necessary. But since blockchain deals with transparency, blockchain is all about transparency. It is a good practice that whenever you are creating your smart contract, you should make your smart contract public in nature. Now, when you will make your smart contract public in nature, again, the chances are high that someone might copy your smart contract, right? And you do not want that. And for that, we have this SPDX license number so that we can tell, okay, this is smart contract is having this license number and this is smart contract belongs to me. So if someone tries to copy your smart contract in future, then you can have a copyright claim on that smart contract, that this is smart contract belongs to me and you cannot copy this is smart. And I've also provided this in your notes. Okay, I will share the notes as well. So SPDX, trust in smart contracts can be better established if the source code is available. As I said, for blockchain, it is a good practice to make your source code available to everyone. Since making smart contract source codes always available always touches on legal problems with regards to copyright, the Solidity compiler encourages the use of machine readable SPDX license identifiers. Every source file should start with a comment indicating its license. So this is what I was saying, right? That you need to have a license number so that there are no copyright issues. And before publishing, consider adding comment SPDX license identifier, SPDX license number, whatever license number you have, and then you can write that. Otherwise, if you have a source code that you do not intend to make it public, in that case, you can have this comment that SPDX license identifier unlicensed. And let's say you want to know more about this, then I will share the link of this SPDX license number website where you can learn more about this SPDX. Okay, I will share the link of this website in the description of this video. Now let's talk about our second thing, that is this Pragma Solidity. What is the meaning of this Pragma Solidity? So whenever you are creating your smart contract, your Solidity language asks you to tell which version of compiler you are actually using for compiling your smart contract. So if we will go to our compile section, we have discussed about it, right? When I was talking about the Remix ID tutorial. So in this, if you will see, we have a lot of compiler versions. So this Pragma Solidity is telling that we can use compiler version of 0.7.0 less than 0.9.0. So if you are going to use, let's say, compiler version 0.5.11, in that case, it will not be a good thing. Okay, so now again, you can see that again and again it is like again and again is going back to 0.8, 1.7. Let me again go back to 0.1.52. I have removed this auto compile button so that it does not auto compile by its own. I'm going just below this 0.7.0, that is 0.5. Now, if you will see, now it is giving an error, right? That your compiler version that you are using is not greater than 0.7.0 and less than 0.9.0. so you cannot use this compiler version. So when you are using this Pragma Solidity greater than equal to 0.7.0 and less than 0.9.0, you can use any compiler version which is in this range. So you can use this. It will not be an issue. You can use, let's say, 0.10.0 as well. It will not be an issue. But if you are going to use any version less than that, 0.6.12, you will see that it will. Now let's talk about contract deployment environment. So if you will see, your Remix ID provides you with a lot of different environment to deploy your smart contract. And we will use some of them in future. But for now, like for understanding, for learning Solidity, we will be sticking to Remix VM London. But once we will reach to the project, then we will start using the other environment that are available in Solidity in this Remix ID. Okay. But for now, for the practice purpose, for like as a beginner, what I'm going to use is Remix VM London. What is this Remix VM London? This is a sandbox environment where you can test your smart contract. So it is providing you an environment where you can test your smart contract, run your smart contract, deploy your smart contract without paying a single amount of money. Okay. So it is like you are testing your smart contract before deploying it to the main blockchain. So it is like a local blockchain that is running in your browser. Okay. So for in the starting, we are going to use this. And once we will reach to our project, in that case, then we will use other contract development environment as well. Okay. So I hope now you have understood what is the use of this SPDX license number, what is the use of this Pragma Solidity, and what is this contract development environment all about, which is providing you an environment to deploy your smart contract. Welcome to our sixth video of our Solidity course series, and in today's video, we are going to talk about state variables. So till now, we have covered so many different things about the Solidity course overview section. What is Solidity, Solidity sample program, compilation process, Solidity SPDX, Pragma, contract deployment environment, each and everything. So now our basics are totally clear, and now we will talk about state variables. So let's start. Now in this video, we are going to see how we can create state variables in Solidity. And to create state variable in Solidity, first of all, we need to create one file in this contracts folder. I will create one file by the name of demo.sol. Definitely you can name it anything, abc.sol or whatever you want. And after creating this file, again, we will copy these first two lines, and I have explained these two lines, right? What is the use of SPDX and what is the use of Pragma Solidity in the previous video. Now, we will give a name to our smart contract. So you can name it as demo or whatever you want. Now inside this, we will create our Solidity state variables. Now what are basically state variables? State variables are basically those variables that you declare within these two parentheses. So any variable that is declared between these two parentheses is a state variable. So let's say if I am creating one variable. So first of all, you have to write the data type of your variable. So here I'm writing uint. Now what is this uint? Uint is basically an unsigned integer data type. We will talk about this, but I hope you are familiar with integer data types, right? Like in C, we have int, in Java, we have int. In the same way, Solidity provides us with this data type uint, which we will talk about in detail in our upcoming videos. So first of all, you have to write this data type. Then you have to mention the name of your variable. So let's say the name of my variable is num. Okay. Now after mentioning this, either you can put a semicolon. Okay. You can do this, or you can initialize your state variable here only. So let's say uint num equal to 5. So you can do this. Okay. Now, in order to see the value of this state variable, let's say if you want to see what is actually stored in this num value, in this num variable, in that case, you should make this num variable as a public state variable. And we will talk about this public specifier in our upcoming videos. For now, just take my word that whenever you write this public keyword before any state variable, you can actually see this state variable. Now, what do I mean by see it? So let's say, first of all, let's compile our smart contract. And I'm just clicking on this auto compile, guys, okay? So that it can automatically compile my smart contract. I do not have to again and again click on this compile button. and I am selecting the 0.8.17 version. Definitely you can choose any of them, but I'm selecting the latest version for now. And now once it will get compiled, you will see a green tick here, and now we will deploy it. So I will click on this deploy button. Okay, so now my smart contract is deployed, and here you will see your num variable. So this is your num variable, right? Now when you will click on this num variable, you can see that your value 5 is stored in this state variable num. Okay, let me write it that this is a state variable. Now there is another way as well in which by which actually you can initialize your state variable. So what you can do is you can also create this constructor. So if you are from object oriented programming background, then you might be knowing this, that constructor is a special kind of function, and we will talk more about it in our upcoming videos. But for now, we can have this constructor, and inside this constructor as well, we can initialize or we can change the value of this smart contract num variable like this. I can do this as well. And if I want, I can remove this previous value. Okay. And now if I will again deploy it, so again, this is our deployed smart contract. When I will click on num, you can again see now it is initialized with 10. Okay. And there is another way as well. Now I know there are so many ways, right, to change the value of your state variable. And that another way is, let me comment this out, that you can create one function, and function will be our next topic where we will be talking about functions. But for now, I am just creating one function. Don't worry about the syntax for now. So function name is, let's say, setter, and in this function I want to set this value. I will make this function public so that I can call this function. Okay, and then I will simply have this. I will have one more thing, and okay, I will not require any more thing. I can simply initialize this value, let's say, to 100. So this is also another way by which you can initialize your state variable. So let me delete it. Let me again deploy it. So now again, you can see that now you have two variables. You have the setter functions, actually not two variables, two buttons. So you have this button for this setter function and for this num. So now when I will clock this num at this point of time, since it is not set yet, you will see that initially it is showing 0. And the reason is because num is a uint kind of data type, and for uint data types, if you are not going to initialize a variable, then by default it will have 0. Okay, but again, we will talk more about this in our upcoming videos. For now, when I'm calling this setter function, and again when I'm calling this num function, and how do I know this setter function is successful? Because you will see that there will be a green tick once you will call this setter function. Let me call this again. Again, you can see that there is a green tick, right? So this setter function is successful. Now when I will call this num, so you can see that we have this value 100. So this is how you can set your state variables. Now let me share some important points related to state variables. So state variables are those variables which cost you huge amount of gas. So whenever you are creating state variables in your Solidity smart contract, you need to be very much cautious because they are going to consume huge amount of gas. And we have discussed about gas, right? About Ethereum gas limit. So you have to be very much cautious here whenever you are creating a state variable. You should create state variable whenever it is required. Do not try to create state variable everywhere. If you think, okay, I need a state variable, then and then only create this state variable. Now, another important thing about this state variable is that whatever value you are going to store in this state variable, that will be getting permanently stored on the blockchain. So the first thing is, I will share the PPT as well, but the first thing is that they are costly, and second thing is they get permanently stored on the blockchain. Permanently stored on the blockchain, and that's why they are costly, because you are renting the blockchain on permanent basis. So permanently stored on blockchain. Okay, so remember these 2 points. So you have to be very much cautious whenever you are creating state variables, but you will learn more about it as you will progress throughout the course. For now, I just want you to know these 2 points. Now let's see some of the important points related to these state variables. First, To change the default value of the state variable, we can do three things, right? As we have seen also, that we can change the value using the contract constructor. We can initialize the variable at the declaration time only, and then by calling this setter function, right? Some other important points related to state variables. First, they are getting permanently stored on your blockchain on your contract storage. So when I'm saying contract storage, actually I'm telling that it is getting permanently stored on your blockchain. Okay. Then they are expensive, so you have to be very much. And the third point is that reading of state variable is free. So you can read your state variable, you can just view your state variable. So if you want to read data from your state variable, like we were doing, right? When we were calling this num variable, we were just reading from the state variable. But whenever we were changing the state variable, whenever we were changing the value of the state variable, when we use the constructor, we were changing the value from of the state variable, right, by having num equal to 5. Or when we were using this setter function, we were actually writing to the state variable by doing num equal to 100. So by these things, we are actually changing the state variable, and changing the state variable is again a costly thing. So declaring the state variable is a costly thing, writing to the state variable is a costly thing, but reading of state variable is totally free. You can read any data that is available on the Ethereum blockchain for free. But writing or changing the state variable is a costly thing. Now in this video, we are going to talk about local variables in Solidity. So what are basically local variables in Solidity? Local variables in Solidity are basically variables that we declare inside a function. So let's say if I'm creating one function, okay, and we will talk about the syntax part of function in the next video. But for now, let me create one function by the name of local. Okay, so local, and this is, let's say, a public function, and in this I'm just, let's say, returning one local variable which is of uint type. So here let's me declare one variable, for example, let's say uint a, and let's say uint b. So both of these variables that you are seeing on your screen, that is uint a and uint b, are basically local variables. Why they are local variables? Because you are declaring these variables inside this function body, right? So that's why they are called as local variables. And this warning is there because we are not actually utilizing these local variables. So let's say if I'm going to use them, then you will not see this warning. Let's say, for example, I am returning a plus b value. In this case, you will not see. Oh, okay, yes, one more thing I have to write here, that is view. Sorry, not you, actually, pure. Okay, again, we will talk about all these things. But for now, these two variables that I have declared inside this functions are basically known as local variables. Like in the previous video, we talked about state variables, right? State variables are those variables that are declared between these two parentheses, right? So if I'm declaring some variable, for example, uint c here, yes, uint c basically is a state variable, while these two variables that we have declared inside the function are basically local variables. Okay, this is a local variable and this is a local variable. Nice. Now, how these local variables are different from our state variable? So basically, local variables does not cost you any gas. Like in case of state variable, we learned that writing to the state variable cost you some amount of gas, right? Declaring your state variable cost you some amount of gas because you are occupying some space permanently on the blockchain, on this storage area of the blockchain. While in case of local variable, that's not the case. You are not occupying a permanent space on the blockchain. Okay, so you are using these local variables only till the time this function exists, and after that these local variables get destroyed. So these local variables do not cost you any amount of gas. Okay, whether you are writing to the local variable or whether you are reading from the local variable. So this is the first difference. And second difference is that local variables are variables that do not get permanently stored on the blockchain like our state variables, which get permanently stored on the blockchain. And you will understand this behavior more when we will progress throughout the course. But for now, these are the two major differences between state variables and local variables. So what are local variables? Declared inside functions and are kept on stack, not on storage. So what is this stack? Stack is also an area. We will talk about this, that we have actually three types of area in Solidity. One is stack, another one is storage, and third one is memory. And we will see the difference between stack, storage, and memory in the upcoming videos. But local variables for now are kept on stack and not on storage. while our state variables are basically kept on our storage, and that's why they cost us gas, because storage is an area which actually permanently stores all your state variables. They do not cost you any amount of gas, while in case of state variables, as we have studied before, it costs you some amount of gas, right? So I hope now you are very much clear with the concept of local variables, and in the upcoming videos we are going to talk about functions, storage, and everything. Okay, so meet you soon in the next video. Now in this video we are going to see how we can create functions in Solidity. So first of all, let me create one state variable, and we have talked about state variable, right? So let's say this is num, and then let's say I want to create one function in order to set the value of this state variable. So in order to set the value of this state variable, let's say I want to create one function. So remember, whenever you are creating functions in Solidity, you have to start with this keyword function. Okay. Then the name of the function. So let's say the name of this function is setter. And then inside this small bracket, we will pass some argument that we want, like with the help of which we will set this num state variable. So let's say I'm passing this uint num, and now this thing that I'm doing this, right, this underscore that I have written, this is not compulsory, guys. You can definitely write any other thing as well. You can do that as well. That's not compulsory, but it is a good practice, I will say, because since you are going to use this value to assign into this state variable, so you can have this type of declaration. Okay. Now after this, we will make this function public, and we will talk about this visibility specifier. There are basically 4 visibility specifiers in Solidity, and we will talk about this. But for now, till the time I'm not teaching you visibility specifier, I'm going to use this public keyword with these functions. Okay. So this public keyword will actually make sure that my function is available to the public, or I will say this function is available to the outside world. And definitely I will talk about this in much more detail when I will talk about visibility in Solidity. Okay. But for now on, we will just use public as this visibility specifier for all the function we will create. Okay. Now we will have this curly braces and then value of this num, and inside this I will assign the value of the num that I am passing as an argument to this setter function. So this is our first function. This is our setter function. Let's say I want to create one more function, that is a getter function, to get the value of this num variable. So how I can do that? So I will write function again. Again, this will be a getter function. So this is the name I'm giving to this function. Definitely you can give any other name as well. Since I'm going to get the values, I'm not passing any value as an argument. Like in this case, I pass this uint num, right? Then I will make this function public again. And here I'm using one more keyword, and the name of this keyword is view. Now I will talk about this keyword in our upcoming videos, or I will say in the next video only, where I will talk about what is this view, what is this pure that we use with these functions. But for now, let me give you a hint that whenever we are reading a state variable, we write this view keyword. Since in this getter function, I'm going to read this state variable, that's why I have written this view keyword, and you will understand. Then we will write this returns, and then the data type of the variable that we are returning from this getter function. So in this case, since we are going to return this num variable, that's why I'm using this uint, because this num is of type uint. So this is the data type of the variable that we are going to return from this getter function. Now this returns is actually not return that we normally use in functions. So let's say if I am writing return here, this return and this returns are two different things. So this returns is actually telling the data type that I am returning from this getter function. This return will actually return the variable that I want to return, or variable or whatever I want to return from this function. So in this case, I want to return num. So that's why I will write num here. So in this way, actually, we can create a getter function in Solidity, and this is how we create a setter function in Solidity. Now in this case, as I said, that we are using this view keyword, and we use this view keyword whenever we are reading from the state variable. And if you will see, this num is a state variable, And since we are using this num, we are reading this num inside this getter function. That's why I have written this view keyword. Okay, but more I will tell in the next video. For now, let me deploy this. Okay, let me compile this first. I can select the latest Solidity version and I can go for auto compile as well, that it will compile and I can check whether my contract is having any kind of issues or not. Now it is totally fine. I can go for the deployment section. I will deploy this. Now in this, you will see that we have three values. One is of num, that is this public state variable, and then this value of getter, and then this setter as well. So initially, if I will call this getter function, this will return us 0. Now why this is so? In Solidity, we do not have any concept of null or none kind of thing. Like in other programming languages like C, we have this concept of null, right? But in Solidity, we do not have any such concept. So in Solidity, whenever you are declaring a variable and you are not initializing that variable, in that case, the initial value of that variable will be according to its data type. Like, what do I mean by that? In this case, if you will see, this num is of uint type, right? So data type of this num variable is uint, and for uint type data type, whenever you are declaring a uint type data type variable, in that case, and yes, you are not initializing that variable, in that case, you will see the value will be, by default value will be 0. And in string, the value will be different. And we will talk about this when we will talk about string. We will talk about Boolean, then we will talk about that as well. Since this is an integer type data type, so by default value is 0 if you are not initializing this state variable here. And not only with this, this case is not only with the state variable. If you are declaring any variable inside the function as well, in that case as well, this possibility will be there. Possibility, actually, this rule will apply there as well. Now let's say if I want to set some value to this num variable, let's say I want to set this num with 100, I will call this setter function. And you can see that this transaction is successful. So this actually tells whether our transaction, whether the function that we have called has actually worked or not. So this is green text shows that, okay, this setter function has actually run. Now what I can do is I can again call this getter function. And now you will see that after setting the value of this num with 100, this num is actually changed to 100, right? Earlier it was 0 and now it is 100, right? Now let me tell you one more important thing here. You must be seeing that this num variable, like this num button is also here, right? And if I will call this num value, you will see that, okay, it is also returning us with 100. So just like this getter function, this num is also returning us with some value, and that value is nothing but that value is the value of this num variable only. So in Solidity, whenever you create a state variable, remember this, in Solidity, whenever you create a state variable, and if that state variable is public in nature, in that case, Solidity creates an automatic getter function for that state variable. Means in this case, if you will see, this num is a state variable, and not only it is a state variable, but it is a public state variable. So that's why Solidity created a getter function for this num variable automatically. And that's why when we are calling this num value, which is actually a getter function, if you will see in reference to Solidity, like for Solidity, this num is nothing but it is a getter function. And if you will call this num, it will return the value of this num variable. So like we have created this getter function, Solidity has created a getter function for this num when we created this public uint state variable. So if I will, let's say, create some other variable, let's say for example uint abc, and since this abc is not a public state variable, you will see that it will, the Solidity will not create any button for it or any getter function for this particular abc variable. So if I will again deploy and if I will show you, you can clearly see that for this num we have this button, we have this setter, we have this getter, but for this abc we do not have any button because this abc is not a public variable and Solidity has not created any getter function for this abc variable. Okay, now let's talk some of the important points related to functions. First of all, when you call a setter function, it creates a transaction that needs to be mined and cost gas because it changes the blockchain. Now, what does this statement means? It simply means whenever you are setting a state variable using a setter function. So when I'm saying setter means any function that is actually changing the value of the state variable, the value of a state variable, in that case, it will cost you some gas. Reading a state variable will not cost you any kind of gas. So when we were using that getter function, that was not actually causing any gas. But if we are going to change that state variable using a function, since we are changing a state variable, in that case, we need to pay some amount of gas, and that's what this statement means. So for that, the transaction need to be mined by the miners because this is changing the state of the blockchain. And last point, that whenever you declare a public state variable, a getter function for that state variable is automatically created by Solidity. And we have seen this as well, right? So I hope you enjoyed this video. Meet you soon in the next video. Now in this video, we are going to talk about view versus pure. So in the last video, we talked about functions, right? And in the function video, I used this term view and pure. Now let us understand when we use this view keyword, when we use this pure keyword, and when we use none of these keywords. Okay. Now to understand this, first of all, we need to create one state variable. So let me create one state variable. Now we know how we actually create state variables in Solidity, right? So now function, again function, then the name of the function. So let's say this is a setter function and I want to set the value of this state variable. So again, I'm doing the same thing that we have done in the previous video, then public keyword, and then I will write here nothing. Now, why I'm doing this? Because in this function, I'm going to set the value of num, which is a state variable. Okay. So which is a state variable. So if we are changing, remember this point, guys. So if we are changing the value of the state variable, in that case, we will not write either pure or view. So in this case, since using this setter function, I am changing the value of this state variable, I will neither use view or pure. Okay. Now let's say I want to create one more function. Okay. And this is a getter function, which will actually help us in getting the value of this variable. So returns uint and then return. Okay. Now in this function, since we are reading from the state variable, or I can say that we are viewing the state variable, that's why we will use view keyword here. Okay. So for this getter function, I'm using this view keyword because I am reading from this state variable, right? Because I'm returning this state variable means I am reading from this state variable, then only I'm going to return it, right? Now let's talk about view keyword. So let's say I am creating this random function. Okay. So let me name this function random as well. Okay. You can name this function anything, but just for the sake of fun, let's name this as random function. And again, this is a public function. And now in this function, let's say I want to use a local variable. Okay. So let's say I created this local variable by the name of, let's say, ABC. Okay. So in this case, if you will see, I am neither reading from the state variable or writing to the state variable. In this case, I will use pure keyword here. Okay. So remember this. So it doesn't matter whether I'm changing the local variable or whether I'm reading from the local variable. It does not matter. So remember, whenever you are reading from the state variable, then you will use this view keyword. If you are writing to the state variable, then you will use no keyword. And if you are reading from a local variable or you are changing a local variable without changing or reading the state variable, in that case, you will use this pure keyword. So let's say if I am returning this local variable as well, let's say this in this way, then also I will use pure keyword only. Okay. It doesn't matter, as I said, whether we are returning or changing the state variable. So let's say if I am changing it also, ABC equal to 7, then also it means nothing. I'm going to use this pure keyword only. And if we are neither reading the state variable nor writing to the state variable, in that case, we will use pure keyword. And in a case where we are just writing to the state variable, in that case, we will use nothing, right? As we have discussed in the example as well. So I hope you enjoyed this video. Meet you soon in the next video. Now in this video, we are going to talk about constructor in Solidity. So what are constructor in Solidity? So constructors are basically special kind of functions which are called by Solidity by default. So these are those functions which we are not calling, but Solidity as a programming language is calling these functions. So let me declare one constructor, and before that, let me declare one state variable, let's say num, okay? And let's say I want to change the value of this state variable. So what I can do is I can create this constructor. So as I said, constructor is a special kind of function, and this is something which we do not call, but this is called by the Solidity programming language. So let's say if I will make this value as 10, so what you will see is, so let me compile this first of all. Let me go to deploy, and when I will click on deploy, you will see that now the value of this num is 10. Why? Because now when we deployed our smart contract during the deployment process only, this constructor function got called by the Solidity programming language. Hence, it made the num value from 5 to 10. So you can see here that constructor is a function which is actually being called by the Solidity programming language, and we are not calling this function. Now let me make this point more clear by passing some argument to this function. So let's say uint, let's say for example num, okay? So I'm passing this uint num variable. You can name it as abc as well. I'm just giving this underscore num. So what I can do is I can assign the value of num here, okay? Now let me again compile this. Now, when I will go toward the deployment part, you can see that before deployment, I need to pass this num value, because as I said, constructor is a function that will be called by the Solidity programming language, and it will be called during the deployment of our smart contract. Okay, so now in order to run this smart contract, in order to deploy this smart contract, first I need to pass some argument to this constructor, so that during the deployment, that argument will get passed to this num value, and that num value will get assigned to this num variable that we have declared as a state variable. So let's say I'm passing 100 here, and now when I will call deploy, now our smart contract is deployed, and now when I will call this num value, you can see that now the value is 100. And this is how constructor works in Solidity. Now let us look at some of the important points related to constructor. First thing is that they get executed only once. So you cannot recall a constructor during the deployment part only. Constructor function get called. Second thing, you can create only one constructor, and that is totally optional. So it is not a must that you need to create a constructor, but you can only create one constructor whenever you are creating a constructor function. Remember this point. And the last point is that if you are not going to create your own constructor, then Solidity will create a constructor for you. Then definitely that will not be visible to you, but a constructor will get called, a constructor will get created by Solidity by itself. Okay, so remember these points, that it get executed only once. You can only create one constructor, and that is too optional. And if you are not going to create any constructor in your smart contract, then Solidity will create a constructor for you. Then definitely that constructor will not change any of the values given in your smart contract, because that constructor will be, you can think of it as like a invisible kind of constructor. So it will not be making any changes to your smart contract, but still it will be called by the Solidity programming language. So I hope you enjoyed this video. I hope you enjoyed this constructor section. So meet you soon in the next video. Till then, bye bye. Now in this video, we are going to talk about integer data type in Solidity. In Solidity, we have two types of integer data types. First one is int. Second one is uint. Int can hold both positive as well as negative numbers, while uint can hold only positive numbers. Uint stands for unsigned integer, while int only for integer. Signed and unsigned integer can be of various sizes. So in Solidity, your int can be from int 8 to int 256. In the same way, your uint can be from uint 8 and to uint 256. Now, what do I mean by this 8 and 256? It simply means 8 bits, 256 bits. In the same way, 8 bits and 256 bits. So this 8 bits and 256 bits are actually telling the range of these data types. So if you are having this int 8 type of variable, in that case that variable can hold 8 bits of data. In the same way, if you are having int 256 bits of variable, in that case that variable can hold 256 bits of data. And I'm going to tell you much more about it in our next slide. So int is alias to int256 and uint is an alias to uint256. So if you are writing int, let's say int num equal to 5, in that case you are writing int256 num equal to 5. In the same way, if you are writing uint num equal to, let's say 1, in that case you are actually writing is uint256 num equal to 1. Okay, because uint and int are actually aliases to int256 and uint256. Okay, now by default int and uint are initialized to 0. So if you are declaring any variable which is of either int type or uint type and you are not initializing that variable, in that case by default that variable will hold 0 as a default value, because in Solidity we do not have any concept of null. Okay, so it will hold by default value 0 if the variable is declared as an integer data type. Overflow get detected at compile time. I will talk about this, what is this overflow all about, but for that we need to understand the concept of range. So if we are writing int8, then it can hold values from -128 to +127. In the same way, if we are writing uint8, then this uint8 variable can hold values from 0 to 255. In the same way, if we are having int16, then this is the value that this variable will be able to hold, any variable that is of int16 type. And any variable of uint16 type will be able to hold a range of values from 0 to 65,535, which is actually a huge number, right? Now you must be thinking how I'm getting all these numbers. So I'm just using a simple formula in order to calculate this range. Okay, and we will see a practical demonstration of this also. So just don't worry if you are thinking, okay, what is actually going on. So just don't worry, I will explain you with all the practical examples. First, let us understand this formula. So when we are writing -2 to the power n minus 1, here n actually stands for this bits. Okay, so let's say if we are talking about int8, then we are actually writing -2 to the power 8 minus 1 to 2 to the power 8 minus 1, and then we are subtracting 1 from this whole value. So if you will calculate this, this is actually -2 to the power 7, so it is around 128. In the same way, if you will calculate this, again it is 127, sorry, it is 128, and when you will subtract -1, then it will be 127. Okay, so this is how we are actually getting this range. In the same way, if you want to calculate for this, the formula is simple. You have to simply do 0 to 2 to the power 8 and then -1. And if you will calculate to the power 8, it is 256. So 256 minus 1 is actually 255. That's why we have this range from 0 to 255. Now let us see all this with the help of practical example on our Remix ID. So now let us take an example to understand integer data type. So let's say if I'm writing uint, for example, num, let's see, let me make this public so that it is accessible to the outside world, then num equal to 5. Okay, for example, like this. And if I will deploy this, let's say if I want to deploy this, and if you will go below it, you will see that the value which I will call, okay, so let me call this num, the value that is returned is 5. And if you will see here, it is nothing but uint 256. So as we discussed in the slide, that uint is nothing but this is an alias to uint 256. This is what actually it is proving that. In the same way, if you are going to do int, and if you will again deploy this, you can see the same result. When you will do num, it is int 256 and then the value 5. Now let us talk about the overflow check, right? So let's say if I have this int8, okay, and as we have discussed in the slide that this int8 can hold values from -128 to +127. Okay, So any value within this range will be acceptable to this num variable because this is of int 8 type. So let's say if I'm writing 127, it is absolutely fine. There is no problem in it. But if I will write 128, then you will see that it will throw us an error. Why this error? Because it is a overflow situation, right? Because this variable, this num variable can hold values up to 127 only, but we are actually over initializing it, right? We are actually providing it with a value which is more than 127. In the same way, if you are going to do, let's say, minus 129, again you will see that it will throw an error because it can only hold values from minus 128 to plus 127, right? Now let us say the same in uint type. Okay, so for uint type, as we have discussed, the range is from 0 to 255. So if we are going to write a negative one in this case, you will see that it will throw an error. Why? Because uint8 as a, or actually not uint8 only, uint as a data type only holds positive number. Okay, so I cannot have minus one here. I can have a plus one here, but not a minus one. I can have 0 here, but again, not a negative number. Let's say I'm trying to have 256. Again, you will see that it will throw an error that, okay, this is not within the range and this is a overflow situation. Okay, so this is how we use uint in case of Solidity. And one more thing, right? One last thing, that if I am only going to have, let's say, uint public num, and I'm not going to initialize this particular variable. Now in this case, if I will deploy this, let me delete the previous one and let me deploy this once again. If I will call this num, you will see that now it is holding 0 because, as I said, if you are not going to initialize a uint type or an int type variable actually, then by default value of that variable will be 0. And you can see here, right? If you are going to check for the int one as well, you can see the same result. So let me deploy it again, checking num, and it is again 0. Okay, so I hope you enjoyed this tutorial. Meet you soon in the next video. Hi, now let us see how we can create loops inside Solidity. Now Solidity, like any other programming language, consists of 3 loops. Okay, first one, our while loop. Okay, while loop. Second one, our for loop, and the third one, our do while loop. So I'm assuming that you already know the concept of loops because that was the prerequisite of this course, that you should have knowledge of at least one programming language. So I'm going to give you a quick demonstration of how you can use loops in Solidity. Okay, I'm just going to quickly tell you how you can use loops in Solidity. Now remember one thing, you cannot create loops at contract level. You have to create loops inside functions only. So if you want to create a loop, first of all, you need to create a function. So let's say my name of the function is, for example, while. Okay, because we are going to create a while loop. Then inside this, we will have our public, not inside this actually, we will make this function public, then pure, and let's say it is returning something. Okay, say uint. Now, in order to use this while loop, first of all, we will have this while keyword, and then these small brackets where we will be having our condition. So if the condition inside this while loop is true, then we are going inside this particular while loop. If the condition inside this small bracket is false, then we are actually terminating from this while loop. Okay, so let's say I want to find the sum of let's say some n numbers. So what I can do that, I can simply create, let's say, a variable sum which will be initially 0, right? Because we are not initializing it with anything. Then we can create one more variable by the name of count. Okay, so this will be having the count. Okay, and we can check whether the count is, let's say, less than 5. Okay, and inside this loop we will simply do sum equal to sum plus count. Okay, so until or unless this condition is true, we will be doing this particular thing. Otherwise we will be terminating from this loop, and then we will returning the value of this sum variable. So now let us check this. Let me deploy this contract. So now I'm calling this while loop, and since you can clearly see that sum is adding to this particular count. Okay, one more thing, we haven't done that we need to have count equal to count plus 1. Otherwise this loop will run for infinity, right? Because we are not increasing the value of count, and count will always be less than 5, so definitely it will never terminate. So we need to increase the value of count after each and every iteration. And now we will deploy it again. Now I'm going to call this while loop. So you can see that 10 is the answer, and that's true as well, right? Because 1 plus 2 plus 3 plus 4 is equal to 10, and that's what this while loop is doing. Now let's say I want to create a for loop. Then what I can do is I can simply remove, or let's say can remove this while loop, or let me comment it out so that you can check it afterwards. Then we will have this for loop, and to use this for loop again, I'm going to have this count variable. Okay, and let me initialize it 0 here. Okay, what we can do is we can simply remove it from here, and we can have it. Okay, and then we will have count should be less than 5, then count should be plus plus, right? The same thing that we were doing inside the for loop, we are doing those things in this for loop statement, okay, inside these small brackets. And then we will copy this line, not this line, actually this line, and simply sum equal to sum plus count. And now we can check this as well. Let me deploy this, and let me call this while loop. Again, the answer is 10, right? Now let me quickly tell you how this for loop is working. First of all, we are going to for this line count equal to 0, and whether count is less than 5, which is 0 is less than 5. Then we are going to this line. Then we are again going to, not actually again, we are going to this line count plus plus. So now count value will be 1, and whether count is less than 5, which is true, again we are going for this line, and this is how this whole loop is working. In the same way, what we can do is we can use do while loop. So do, and in this we will have our condition here, that is whether count is less than 5. Okay, and yes, remember to put this semicolon at the end, and just copy the same statement that we have in our while loop inside this. Okay, and just comment this, and just again we will have our count declared, okay, like this. So now again we have this do while loop, which is actually doing the same thing that this for loop was doing and this while loop was doing. So deploy while loop again. Okay, I'm not changing the name, okay guys, so don't worry. Okay, that like I'm calling the while loop, why it is doing the do while loop kind of a thing. Okay, so now you can clearly see that 10. Okay, so this is also working in a right way. So this is how we use loops inside Solidity. I hope you enjoyed this video. Meet you soon in the next video. Now in this video, we are going to talk about conditionals in Solidity. So when I am saying conditionals, I am talking about if-else condition inside our Solidity programming language. So like any other programming language, we can use if-else condition inside Solidity as well. The only thing is that we cannot use if-else condition at contract level. So like our loops, we need to create if and else condition. In order to use if and else, we need to use functions. So let's say I want to create one function. Let's say it is checking whether a number is greater than or less than. Okay, so like something like that. So let's say uint a, b, and then public po, and then returns. Okay, and then let's say I want to check whether a is greater than b. So if a is greater than b, then inside this what I'm going to do is, let's say I want to return 1. Okay, else what I'm going to do is I'm going to return 0. So this is how we actually use if else inside our Solidity. So if this condition will be true, then it will return us with 1. If this condition will be false, then it will return us with 0. So now let me deploy this. So let's say I'm passing 2 and 3. So definitely this condition will fail. So it will go to this else condition, checking. So here you can see that it is returning us with this 0. Now let's say you want to also check whether a and b are equal. Then what you can do is, instead of just having else, you can also have else if. Okay, so as I said, like any other programming language, you can use else, if else, like all these things that you might have used in any other programming language. So let's say if else if a equal to b, in that case what I can do is I can return, let's say 2. So anything, it's just to demonstrate you that how we can use if else condition inside Solidity. Okay, so now if we will check deploy, and now let's say I want to check for 2 and 3, which is okay 0. Let's say I want to check for 3 and 3. Now you can see that it is returning us with 2 because 3 is not greater than 3. So it is going for this. 3 is equal to 3. That's why it is returning us with this 2. Okay. So this is how you use if else condition inside your Solidity programming language. I hope you enjoyed this video. Meet you soon in the next. Now in this video, we are going to talk about Bool data type in Solidity. So Solidity, like any other programming language, also supports Bool data type. In order to declare a Bool variable in Solidity, we have to simply write Bool. Okay, so this is the Bool data type. Then public in order to make this value variable visible. And then this variable name. Definitely I have written value here, but you can choose whatever name you want. And then we assign some value that is true because Bool data type only supports either true or false and nothing else. If you're trying to assign something else other than true or false, it will not work. Okay. By default, value is false if not initialized. Means if you are declaring a Bool data type variable and you are not initializing that variable, in that case, by default value of that variable will be false. Now let us see all this on our Remix IDE. Now let us declare a Bool data type variable inside our Solidity program language. So first of all, we will write this Bool keyword. Okay, so this is the data type. Then public in order to make this variable public in nature. And then the variable name. Let's say the variable name is, for example, value. And then we will assign some value to it, which can be either true or which can be false. Okay. And if you are not going to initialize this variable with anything, then by default value of this value variable will be false. And you can see that. So let me deploy this. Then we will call this value variable. So here you can see that by default value of this value variable is false. If you will initialize it with true, then you will deploy this. Okay, file it first, then deploy it. Now if you will check the value, it is true. Okay. Now where generally we use this Bool data type? We generally use this Bool data type especially whenever we have our conditional kind of statements. So let's say, for example, we have this function by the name of check even. Okay, it's checking whether the number is even or not. Then we will pass some value to it. And then let me make this function public, is pure, then returns. And then what we will do is we will simply check if a ampersand 2 is equal to 0. Okay, if this is equal to 0, then we will return. Okay, I made one mistake here because we are returning a Bool type value, right? So we need to have Bool here, and then if this is not true, then we will return false here. Okay, let me compile this, deploy this contract. Now I will pass some value, which is, let's say, even 12 number. So now you can clearly see that when I'm passing 12 here, since 12 m% 2, not m% actually, a modulo 2 equal to 0, then it is returning us with true. And if a modulo 2 is not equal to 0, then this is us with false. So this is where we use Bool data type in Solidity. Definitely there are various other uses as well. I'm just giving you one of the ways where you can use Bool data type. So I hope you enjoyed this video. Meet you soon in the next video. Now in this video, we are going to talk about require statement in Solidity, which is a very important statement in Solidity and a concept that you should know. So in order to understand require statement, let me create one function by the name of is 0. Okay. And let me pass some value to it, public, and it will, let's say, return, for example, true. Okay. Not true actually, Bool value that. And then definitely have curly braces. Since we are not using any state variable, so we can have pure here. Now what I can do is I can use my require statement to check whether a is equal to 0 or not. So I will do require. I will check whether a equal to 0. If a is not equal to 0, then I will throw an error that a is not. And if a is equal to 0, in that case, we can return true from here. So let us see what I'm trying to do here. So I will pass one value a to this function. This require statement will check whether a is equal to 0 or not. If this condition is true, then we will go to the next line. If this condition is false, means if a is not equal to 0, in that case, it will throw an error that a is not equal to 0. Let us check this first. So I will deploy my contract. Now I will pass some value. Let's say I will pass 0 for the, like for now, I'm passing 0.
So you can clearly see that since a is equal to 0, so it will pass, this condition will pass and it will go to the next line and it will return us true. Okay. Now let's say if I'm passing 12 here, okay, which is not equal to 0, and I will click on this is 0. Now once I will click on this is 0, you can clearly see that this transaction got failed. So here you will see that the transaction has been reverted to the initial state. Reason provided by the contract a is not equal to 0, and definitely if you want to know about it, then you can debug this transaction. But here this is an important point, that your transaction got failed because a is not equal to 0, and it throws this error that a is not equal to 0. Now you must be thinking whether require statement is an alternative to our if and else condition. So it depends. So for example, let me use if and else condition for the same function. Okay, I will create one more function. Okay, and let's say instead of using this, what I can do is I can check whether a equal to 0 using my if else condition, and then simply if this is true, I will return this true. And if this is not true, what I can do is, okay, in order to use this, just like our require statement, I have to use another keyword, and that keyword is revert. Okay, and then inside our revert we will have this particular statement like this. So now what will actually happen is that it will check whether a is equal to 0. If a is equal to 0, then it will return true, and then we are reverting. Okay, let's close this bracket. If this is not the case, okay, if this is not the case, then we will revert with this particular statement. So this revert will actually behaves like just like your require statement in this case. Actually, not as your require statement, because in require statement you can also mention your uh, condition as well, right? But in this case, I have to use this if condition. But this this revert statement actually will throw an error just like your require statement. If you will return a string directly from here, then that will not be considered as an error. So if you're thinking that I will return this like this, what I'm trying to say. So instead of reverting it, if you are thinking I will directly do return, and inside this I will pass this particular string. Definitely you can do that. You can do that and it will definitely work. But here you have to understand that this is not an error, okay? While this is like throwing an error. And in this case, you are simply returning one string and it is not throwing any kind of error. That's why instead of this, what we will use is we will use this revert statement if we want to act like, if we want this function to act just like our is0 function. Okay, so let me move all these extras. Let me save this. Let me again deploy this. Okay, let us check whether our is0 if condition is working or not. So I will pass 0 for the first time. So it is returning us true. Nice. And let's say if I'm passing 12 in this case. So again, you will see the transaction has been reverted to the initial state, just like your require statement, if you remember. Reason provided by the contract is not equal to 0. And again, the debug the transaction to get. So yes, you can use this require statement as an alternative to your if else condition, but only if you are using this revert statement, right? Because this revert statement will throw an error just like your require statement. Okay, but definitely you do not need to get confused. Better, like the best will be to use this require statement only, because in most of your projects, in most of the examples that you will see, most of the people, most of the developers use this require statement, not this revert, because this will just expand the lines of code, right? This require statement is doing everything in this single line of code, while for this, for the same thing to do with if else, you can clearly see that I have to have 2 more extra lines, right? So definitely require statement is a much better alternative to this particular. I hope you enjoyed this video. Meet you soon in the next video. Now in this video, we are going to talk about modifiers in Solidity. So if you remember, we have used require statement in the previous video, right? Now let us try to use the require statement again. Let me create one function by the name of f1, and let me make this public. We are not going to do anything with the state variable. And in this, I am simply doing require, for example, we are just checking whether true is equal to true or not. So this is just to, just for the demonstration purpose, so that I can make you understand one important point about modifiers. So let's say true is not true. If something will be false, then we can simply do and then we will simply return some value from it. Okay. In the same way, let me copy this thing again. Let me paste it here like this. Let me change the name of these functions. Let's say I am returning some different values every time. F2 I'm returning 2, from F3 I'm returning 3, and from F4 I'm returning 4. Okay, let me save this. So if you will see that this is a good contract. uh, F1 is returning us with 1, F2 is returning us with 2, F3 is returning us with 3, and then F4 is returning us with 4. But if you will see, we have a lot of repetition in this particular code, right? We are actually repeating this require statement again and again, right? We are actually repeating this require statement again and again. So what we can do in order to avoid this repetition. So instead of using this require statement again and again, what we can do is we can use modifier. So I can create one modifier by writing this modifier keyword, and then the name of this modifier. Let's say the name of this modifier is true. Okay, definitely you can name this modifier whatever name you want, and then simply this curly braces. And now inside this modifier, I will copy this thing inside this modifier like this. And after that, what I will do is I will have an underscore and semicolon like this. And now what I can do is, instead of using this require statement, I can remove all these require statement from here. Okay. And I can use this modifier name along with these functions. I can have my modifier name here like this. And now my function will behave just like before only. Now, instead of rewriting the require statement again and again in all these functions, what I have done is I have used this modifier which has actually avoid the repetition of code in my particular contract, in this particular contract, right? And we can check that as well. So let's say, for example, I'm deploying this, okay? And let's say I'm calling F1, F2, and F3 and F4 because definitely is true for every condition, so it is not throwing any error, and that's why we are able to call this F1, F2, and F3 and F4. But let's say if I'm trying to change the value here, I'm trying to compare whether true is equal to false, which is definitely false, right? Can never be equal to false. Then let me again deploy this, and now if you will see, when I will call this F1 function, it will throw us an error, because what will actually happen when we will call this F1 function, it will again go to this require statement. It will check whether true is equal to false, which is actually false, and then it will throw this error that true is not true. Let me call this F1. So here you can see that, okay, I think I haven't compiled this contract. That was the problem. Sorry for that. Actually, I should make it auto compile. Let me again deploy this, guys. Sorry for that. Let me again call this F1. Now you can see that it is throwing an error. That transaction has been reverted to the initial state. Reason provided by the contract, true is not. Let me call F2. Again failed, again failed, again. So this is how we actually use modifiers in order to avoid this repetition of code in Solidity. Now definitely you must be wondering, what is the use of this underscore here? So it's simply what this underscore is actually doing is, it is simply copying the remaining code, okay, like from this F1, since we are using this is true with this F1, it will copy this line and it will paste this line here, okay, like this. And now when we will call F1, it will check for this and then it will return this if this is true. That's why we have this underscore, so that we can paste the remaining code inside this underscore. But you do not need to go in depth of this particular thing. If you know how to use modifier, that's more than enough. So in the previous video, we have seen how we can use modifiers in Solidity, right? And now in this video, we will talk about how we can pass arguments to the modifier. So let's say if we talk about this particular function, in this function, if you will see, I'm passing one value a, and this require statement is checking whether this a is an even number or not. So if it is an even number, then we will return true. And this, if this is a false, means if this is false, then we will throw this particular error that a is not even, right? Now let's say I want to use the same thing with the help of modifier. So what I can do is I can go here, I can write my modifier, then the name of my modifier, let's say, is even. And in this, since we are passing some value, so I will have a uint a like this, and then we will simply again cut this require statement here and we will paste it. Again, we will have this underscore and then semicolon. Now, since we are not using any require statement here, we need to use this modifier, right? So I will take this modifier, I will paste it here. Now, our work is not done because in the previous video, if you remember, we were not passing any kind of argument. But in this particular function, we are actually passing a as a value, right? So what we will do is we will simply write a here so that whatever value we are going to pass inside this function, that value will get passed to this modifier as well. Then this modifier will check whether the required statement is working or not. So let me compile this. I have some error. Let me check this error. Okay, so it is saying that, okay, I have written, sorry guys, again, I have made this mistake. It should be Bool here, right? And again, I'm mistakes. So let me compile this. Now let me deploy this. Now let us check this. So let's say if I'm passing 12, which is an even number, so it will return true because this will pass, and then when this will pass, it will return this true statement. So here you can see that it is returning true. But let's say if I'm passing some odd number like 1, call this up, and now let me call this F1, you will clearly see that it is throwing an error that A is given. So this is how you use modifiers with an argument, okay? So if you have multiple arguments, then definitely you can increase it, okay? Just like your function, and you can pass that particular argument to this modifier. So I hope you enjoyed this video. Meet you soon in the next video. Hi. Now in this video, we are going to talk about address data type in Solidity. So what are address data type in Solidity? Address data types are those data types which actually holds our addresses. Now this address can be an externally owned account address as well as a contract address. So in this case, if you will see, I have simply declared this address type variable addr. Okay, this is of address type, then this is public, and this is the variable name. Now, one important thing that you need to remember about this address data type is that you cannot perform arithmetic operations on this address data type. Now, one important thing that you need to remember is that you cannot perform arithmetic operations on this address data type. So if you are thinking that whether I can add two addresses, whether I can perform multiplication between two addresses, so that is not possible in Solidity programming language. Now let us go to our remix ID in order to check it. Now let us understand how we can use address data type in Solidity. So first of all, we will write this address, okay, data type name, what means data type, and then the visibility of this variable, that say public, and then the variable name. So I'm naming it as addr. Definitely you can name whatever you want. Let's say I want to store some addresses into this addr. So what I can do is I can simply go to Solidity, to the deploy section, and here you can see that we have different addresses, and we can copy one of those addresses and paste. This is how you can use address data type in Solidity. Now we will talk about address data type much more when we will talk about payable functions and payable addresses, because then we will actually see the use of address data type. But for now, just remember that address data type are basically used in order to store addresses. And in the upcoming sections, when we will talk about payable addresses and payable function, then we will also see one of the most important applications of this address data. But for now, just remember it is a data type which is actually helping us to store addresses of an externally owned account or of our contract account. So I hope you enjoyed this video. Meet you soon in the next video. So till now, whatever we have studied so far was mainly about basic data types. So we talked about, if you remember, integer data type, we talked about Bool data type, we talked about address data type, right? Now from this video onwards, we are going to talk about reference data type. Now some examples of reference data type are strings. Okay, your string is a reference data type. Your arrays is an example of reference data type. Mappings as well as struct is also an example of reference data type. So let us have a close look about these reference data type, like why they are known as reference data type and how we can use them in our Solidity programming language. So if we talk about data types such as arrays, structs, mapping, all these are examples of reference data type. And if we use a reference data type, we always have to explicitly provide the data area where the type is stored. Now, what does this particular line means? It simply means that whenever you are using a reference data type,
then you have to tell Solidity like for which area you are using this reference data type. Now I will explain this sentence once we will go back to our remix ID, where there I will explain you this in a much more better way. But for now, remember that reference data type has a memory area allocated with it. Okay. So every reference data type has an additional annotation, the data location about where it is stored. So it is actually telling that where your reference data type is actually being stored. And there are basically three data locations, that is memory, your storage, and call data. And we will talk about all these memory storage one by one with the help of an example in our upcoming videos. So now let us have a look at all these data locations. So data location and about their features. Okay. So first data location that we have seen was memory. And if we talk about memory, its lifetime is limited to an external function call. So whenever you are using, reference data type with memory keyword, then the lifetime of that particular variable is limited to that particular function only. And we will see that once we will start talking about these reference data types. So don't worry about it for now. I know it might sound confusing, but don't worry. Once we will start with examples, you will get each and everything. Okay. Now storage. And if we talk about storage, the location where the state variables are stored, where the lifetime is limited to the lifetime of a contract. So whenever we store our state variables, right, we have talked about our state variables. And I told you, right, that state variables are those variables that are getting permanently stored on our blockchain. And our state variables are actually getting stored on this storage area only. And that's why their lifetime is limited to the lifetime of a contract. Means these are those variables that are permanently getting stored and nobody can remove these variables. In the same way, whenever you are declaring these reference data type variables and whenever you are storing them in storage area, means at contract level, then you are making sure that these variables can never be destroyed. While in case of memory, the variables can be easily destroyed once the function call is over. Then the third one is call data. And call data is a special data location that contains the function arguments. Okay. And we will talk about the difference between all these memory locations one by one. But for now, just have a look at all these data locations. And then we will start with arrays. Then we will talk about strings. Then we will talk about mappings. And then we will talk about structs in our upcoming video. Now in this video, we are going to talk about arrays in Solidity. So if we talk about arrays in Solidity, there are basically two types of arrays. First one, your fixed array. Second one, your dynamic size array. And in this video, we will talk about fixed array, and in the next video, we will talk about dynamic size array. So what are fixed size array? So as we all know that array are collection of homogeneous elements. So if we are having array of integers, then we will have only integer elements inside that array. If we are going to create a string type array, then we will have only string elements inside that array. And what do I mean by fixed array? And what do I mean by fixed size array? Fixed size arrays are those arrays which has a fixed size at compile time. In Solidity, this is how we declare a fixed size array. First of all, the data type. So we are using uint here. Then the number of elements that we want inside this ARR array, and then public and this ARR variable. So if you are writing uint5 public ARR, then in memory, something like this is happening. Since you are not initializing this array, by default, all the array elements will be 0 because this is of uint type array, right? So all the elements at index 0, 1, 2, 3, 4 will be 0. Now let's say if you are declaring an array by initializing it with 10, 20, 30, 40, 50, then in memory, it will be like this, where at 0th index, you will have 10, at first index 20, at second index 30, and at third index 40, and so on. Now let us go to our remix ID in order to understand the concept of arrays in a much more better way. So here, in order to declare an array, I will first of all write uint because we are going to declare an integer type array. Then inside this, we will have the number of elements that we want inside our array. Then public and then the variable name. So let me show you that by default, this array will be empty, means
empty, by what do I mean by empty, means by default it will be having 0, right? Since it is of uint type. So let me deploy this and let me check the 0th index. So you can see it is 0. Let me check the third index. So again it is 0, right? Now let's say if I want to initialize this array with, let's say 10, 20 and 30, something like this, 40 and 50. Now in this case, if you will deploy this again, we will check at 0th index, it is having 10, at 5th, not actually 5th, only 4th, right? Because this is a 5 elements array. So we will have only 4th index, 0, 1, 2, 3 and 4. So at 4th index, we have 50. Okay. Now let us see how we can insert an element using a function inside this array. So to insert an element inside this array, we have to write function. Okay. Then let's say this uint item. Okay. I forgot one thing, the name of the function. Let's say the name of this function is insert, and then I will make this public, then curly braces. And now let's say I want to, I can also pass one more thing, right? That is the index value. Okay. And let's say at a particular index, I want this item value. So I can insert that item value here. Okay. In this way, I can choose whatever index I want, and then I can insert that particular element inside that index. And it would be better, right, if we will have the index first and then the item at this position, right? So just to make it more user friendly. Now let's say I want to return some element. In that case, I will write return ARR. Okay. And let's say I want to return a particular index. So uint index again, then public, then returns, and then uint, because the array element is of uint type. So ARR, okay, first of all return, and then ARR index. Okay. And yes, definitely, since we are only reading from the state variable, because ARR is a state variable, right? So we will have this view keyword. And in this, since we were changing the state variable, this state array, so that's why we never used any keyword view or pure here. Okay. So by this, we can insert an element into array or return an element from an array. So let me deploy this so that I can make you understand. So at 0th index, currently you will see it is having 10, right? So let's say I want at the 0th index, I want 100. So I will insert it. So the transaction is successful. If I will again call, you can clearly see that ARR 0 is 100. And same we can do from this return array function, right? In case Solidity has already created a return type function for this ARR variable, because this is a public state variable, right? So that's why we are able to call this ARR 0, ARR 1 using this state variable. But definitely if you will not make this public, then you need this return ARR function. So let me check that as well. So 0, let's say 4th and 50, right? So this is how we can insert and return an element from an array. But let's say I want to return this entire array, okay? Because currently we are only returning a specific element, right? But let's say I want to return the entire array. In that case, what I will do? In that case, I will do return all elements, something like this, okay? So this is just a function, all elements, and then I will make it public. Then since we are going to view the state variable, then view, then returns. Now here comes the tricky part, and let me tell you what that tricky part is. But before that, let me do return ARR. Now in this returns, what we are going to have in this return? In this return, since we are returning this entire array, okay, it should be ARR. Since we are returning this entire array, right? So in this, we have to have uint first of all, because we are returning an array of uint type. Again, since we are returning this entire array, and this entire array is having around 5 elements, right? So it is having 5 elements. So we need to mention that as well. So like this. And then if you will see that I already have written this uint5 like this, right? Still there is an error. So what is that error? So it is saying that data location must be memory or call data for return parameter in function, but none was given. So it is saying that we need to use this memory keyword, okay, this memory keyword in order to make this function work.
Now the question arises, why? Why we have to return this memory keyword? What is the utility of writing this memory keyword here? Since we talked about reference data type, right? And we have seen that arrays are also reference data type. And these reference data type are actually referencing by default the storage area. So they are referencing by default the storage area. What do I mean by that? It means that when we are writing this ARR variable at contract level, so this ARR is actually getting stored in the storage area, right? We have talked about this while we talked about the state variables, right? That state variables get stored at contract storage, right? Now, since you are using this reference data type, this array inside this function, so you need to tell to this Solidity compiler that you are using a reference data type inside a function. And for that, you need to mention this memory keyword. So whenever you are going to use any kind of reference data type in a function, you have to use this memory keyword. And this will make more sense when we will talk about other reference data types as well. For now, just take my word, and whenever you are returning any kind of reference data type, use this memory keyword. But again, as I said, we will talk about this reference data type more in our upcoming session. So as we will progress through different data types, let's say string, mapping, then we will get to learn much more about this reference data type. For now, remember, whenever you are returning an array, and since this array is a reference data type, you have to use this memory keyword inside this function. And another important thing is that you cannot use this memory keyword at contract level, because memory keyword is actually used for the functions only. If you remember the definition that we discussed in the reference data type, that memory keyword are actually related to your external function call. So you cannot use them at contract level. So if you will try to do this, you will see that it will throw you an error that expected identifier but got memory. So you cannot use memory keyword inside this contract level, means at the contract level. You can use memory keyword inside this function, but not at contract level. And we will see how to use memory keyword inside this function as well in our upcoming videos. For now, let us deploy this. And in this, if you will see, we have this return all elements. When I will call this, you can see that it has returned all the array elements 10, 20, 30, 40, 50. Okay. So this is how we perform operations on a fixed size array. I hope you enjoyed this video. Meet you soon in the next video. Now in this video, we are going to talk about dynamic array. Now what are dynamic array? Dynamic array are those array which are dynamic in nature, means their size is not fixed at compile time. So if I want to declare a dynamic array inside Solidity, this is how I declare a dynamic size array inside Solidity. So uint, since I am declaring a uint type array, then in the brackets, we are not going to write any integer, means in the fixed size array, if you remember, we have written 5 there, right? So that we can tell the compiler that we are actually declaring an array of 5 elements. But in this case, we are not going to use any such thing because this array is dynamic in nature. And to insert elements inside this dynamic array, what we have to do is we have to use this push method that is available with this dynamic array. So with this, we can push an element to this array. If we want to pop an element, if we want to remove an element from this array, then we use this arr.pop function. It removes the last element every time it executed. So with the help of this pop function, you can remove the last element from this ARR array. And the third point is that if you want to find the length of this array, then you can use this arr.length function. It will return you the length of this array in a uint data type form. So now let us try all these things on our Remix IDE. Now, in order to declare our dynamic size array, first of all, I am writing uint, then public, and then arr. Okay. Definitely, the name of this variable can be anything. I'm just using arr. You can write abc as well. So let's say I want to insert some element inside this array. For that, I need to have function. Then we need to tell the element that you want to insert. So let's say item. Okay. And then public. And inside this, as we have seen, we need to write arr.push. and then the element, so item. Okay, so you cannot provide any index here because it automatically insert the element at the 0th index, and when you will call it again, it will insert the element at first index and so on. Okay, so you do not require to write any index field here. Okay, in the same way, let's say you want to remove an element, so function remove, let's say remove last element actually. So here you will write again public, and then you can write arr dot pop. Okay, so by this you can remove the last element from an array, from this array actually. And let's say you want to find the length of this array, so length, and then you can simply write public, and since this length, okay, one more thing, we need to have view, then returns, and since this length will be of uint type, so we will do that as well. So return arr dot like this. Okay, I think we made some mistake. Let me see what is the mistake here. Okay, I think I made this mistake. Let me have arr and let me remove this because it does not, it is not required here. So now we can again deploy this to check it. So if you will see, if you will find the length of the array, currently it is 0 because there are no elements inside it. So let's say I want to insert some element, let's say 100. I will click on insert. So now I can check the length. It is now 1 because one element is inserted. At 0th index, it is having 100, right? In the same way, I can insert some more elements, let's say 200, and let's say 300, something like this. So now if you will check the length, it is 3. So 3 elements are inserted. We can check that as well at index 0. So yeah, at index 2, we have 300. Now let's say I want to remove this 300 element. Okay, so to remove this 300 element, what I have to do is I have to simply call this remove last function. And now if you will check the length of the array, now it has decreased from 3 to 2 because we have removed the last element. And if you will check the second index, you will see that it will give you an error. So here the transaction has been reverted to the initial state because the reason is very simple, guys, because at second index now there is no element and we are trying to call that particular element, right? So that's why it is given us this error that you are trying to call an element which does not exist. That's why the transaction has been reverted. But if you will try to call at index 1, there will be no problem because at index 1 we have this 200, right? But at index 2, or let's say at index 3, there are no elements. So definitely it will throw an error that there is no array element. And let's say if you want to call this entire array, if you want to see the entire array, then again you have to write this function. Okay, should be function and return all, and then again public view. And in this as well, since this is a reference type data type, right? So you need to have memory keyword as well. But in this, you will have uint, and then you will have this bracket, square brackets. And this square bracket will be empty because this is also empty, right? And then you need to use this memory keyword again. Okay. And then we will write return arr like this. Okay. And let me deploy this once more. And here I will insert some element, let's say 11, and let's say then 12, and let's say 13. And now when I will call this return all, you will see that 11, 12 and 13 are returned from this arr element, means from this arr array, from this return all function. Okay, so this is how you actually create, insert, remove, find length and return all the elements of a dynamic array. So I hope you enjoyed this video. Meet you soon in the next video. Hi, now in this video we are going to talk about the difference between memory keyword and call data keyword in data locations. So as we have seen that reference data type comes with these data locations, that is memory, storage and call data. And in this video, we are going to see the difference between memory keyword and call data keyword. And in the upcoming videos, we will see the difference between memory keyword and storage keyword. So for now, if you will see memory keyword, their lifetime is limited to an external function call. So they are limited to a function only. Call data, it is also a special data location that contains the function arguments. So let me tell you one thing very clearly here, that both, like all of these things that you are seeing here, right? All of these things are memory areas only. Means these are areas where we are actually storing our variables. Why I'm telling you this? Because it confuses a lot of students that what is this memory storage and call data at the end of the day. At the end of the day, they are just memory areas or storage areas where you are actually storing your variables. And since we are talking in reference to reference data type, so they are actually storing the variables of reference data type like arrays, your structs, your mappings, and your string. Okay. So now let us see the difference between this memory keyword and call data keyword. Now, as you can see on your screen, we have this array, right, of 5 elements. And let's say I want to insert some elements inside this array. Now, in order to do that, first of all, I need to create one more function. And let's say I want to insert an entire array to this array. Means I want to pass an array, let's say insert array, ARR, let's say, and I want to pass an argument, an array argument inside this function. Now, how can I do that? Let me tell you that. But before that, let me make this public. And let's say we have this ARR here, and I want to assign an array which is passed as an argument to this insert ARR function. So how can I do that? Now, in order to do that, first of all, we need to write uint. Okay. And since this array is of size 5, let's say I want to insert 5 elements, I want to assign 5 elements inside this. So what I can do is I can simply write 5 first of all. Okay. And then I can write the name of the variable with the help of which I'm going to assign some element inside this array. So ARR, like this. So if you will see, I am passing an array, right? I am passing an array inside this function, means as an argument to this function, and then I'm assigning this ARR value to this array. Okay. But if you will see, now it is showing us one error. And the error is that data location must be memory or call data for a parameter in function. So again, since we are actually declaring, or I will say passing an array inside this function, so we need to tell this function that this ARR, because this ARR is a reference data type which is referencing storage area by default. So we need to tell that, okay, function, this ARR is actually an array and we want to use this array inside this function. So I'm using this memory keyword. Okay. So again, you have to use this memory keyword. Okay. Again, you have to use this memory keyword so that you can use this ARR array inside this function, because you are passing an array inside this function, right? So you have to use this memory keyword. If this was not a reference data type, then you can directly pass the variable. Let's say if this ARR was simply a uint data type variable, then you do not require this memory keyword. But for reference data type, you need to have this memory keyword. So remember, whenever you are using any kind of reference data type inside a function and you are passing that reference data type inside that function, you need to use this memory keyword. Just like when we were returning a reference data type, right? This array, if you remember from the fixed size array and the dynamic size array, when we were returning those arrays, we were actually using memory keyword there as well. In the same way, you have to use this memory keyword whenever you are passing a reference data type inside a function. So now let us check this as well. Let me deploy this. So now you will see we have this insert ARR. Currently, all the elements are 0, right? Because this is a uint type data type, 0. Now let's say I want to pass an entire array element inside this. So I will simply do, okay, let me simply write here in these square brackets 1, 2, 3, 4, and 5, because this array is of 5 elements, right? And I will click on insert. Now, as soon as I have clicked on insert, you can see that this transaction is successful. Now, if I will check the ARR values, so you can clearly see that at array index 1, we have 2. At array index 3, we have 4, right? At array index 0, we have 1. So this is how you can use this memory keyword in order to pass an array inside a function. But if I will remove this memory keyword, you will see that we have two options. First one was that we can use data location, either memory or call data. Now, when do we use memory and when do we use call data? Let's say if I want to use call data here, then also this is fine. There is no error. We can use this call data keyword as well as we can also use this call data keyword here as well. So now the question arises when we use this memory keyword and when we use this call data keyword. If we are using this call data keyword, right, with this ARR, with this reference data type, now in this case, you cannot make any changes to this ARR variable. Means when you are using this call data, this ARR is now immutable in nature. What do I mean by that? I simply mean that let's say if you are passing this array and let's say you are thinking that at ARR index 0, I want to have, let's say, 10. You are thinking something like this. So you can clearly see that it is not possible. It is showing that call data arrays are read only. Means you cannot change any value inside this ARR variable. While on the other hand, if I will use memory keyword, you can clearly see now there is no error. Because if you are using memory keyword, you are telling the Solidity compiler that, okay, I want to make changes to this ARR, so you can use this ARR. If you can use this memory keyword if you want to make some changes to this ARR array. If you do not want also, you can still use it. There is no problem. But if you are thinking in future, I'm going to make some changes to this ARR variable, then definitely you should use memory keyword. Otherwise, you should use call data so that you can tell the Solidity compiler, see, I'm not going to make any changes to this ARR, so I'm going to use this call data. Now, another difference between memory keyword and call data is that you can use call data only at function arguments. Means you cannot use this call data keyword inside a function or while you are returning a reference data type variable. Like definitely it shows that you can use this call data while returning some reference data type, but you cannot. Call data can only be used inside function argument with reference data type. So if you will see the definition as well, that these are special data location that contains the function argument. While case of memory, you can use memory keyword wherever you want. So if you want to use memory keyword in the return type, means if you want to have a return statement here like this, and you are thinking I want to return this array, so like this uint 5, okay, and then you are doing this kind of stuff, something like this. So let me remove this for now. Okay, let's do one more thing. Instead of making some changes to this, why not we make a different function? Let's say return array. Now in this, if you will see, and let me remove this first of all. So let's say I want to return this array. So returns, and in this, first of all, I will write uint, then 5, because this is a fixed size array. And after this, I can only use memory keyword, okay, to return, let's say, any array, okay, any kind of array or any kind of reference data type like this. And definitely you need to have view here. So you cannot use call data here, okay. Definitely the compiler will show that you can use it and there is no problem in it. Like definitely now it is showing an error, right, that it is not possible, you cannot do this. But if I will use memory keyword, there is no problem. And if you are not going to use anything, it will give you an error that you should use call data, but you cannot use call data. As I said, you can only use memory keyword here. While call data, you can only use in function argument. Second thing that you need to remember, that if you're using call data, you cannot make changes to the variable, to this variable, okay? Because now since you're using call data, it is immutable in nature. But at the end of the day, you have to remember that call data as well as memory are just data locations. They are nothing more. They are used only with reference to the reference data type, not with any other data type. Let's say if you are thinking to use this with uint or let's say with address data type, you cannot use it. You can only use them with reference data types. Memory and call data, these can be used, this memory keyword can be used anywhere inside a function, but this can only be used in function argument. This is mutable in nature, while this is immutable in nature. So I hope you understand what are the differences between memory keyword and call data keyword. So I will meet you in the next video. So in the previous video, we talked about the difference between memory keyword and call data keyword, right? Now in this video, we are going to see the difference between memory keyword and storage keyword. So if you see the definition of memory keyword, its lifetime is limited to an external function call, okay? And storage, the location where the state variables are stored, means the contract area where we are actually writing our state variable, that area is known as storage area, and this is that location. where the lifetime is limited to the lifetime of a contract, means whenever you are declaring your state variable, they are getting permanently stored on the storage area of your data blockchain. Okay. So now let us see the difference between this memory keyword and this storage keyword. So on your screen, you are seeing that we have this array of length 3. Okay. And now let me create one function by the name of fMemory. Okay. And then I will make this function public and I will have view keyword. And in this, I will simply do one thing, that I will create one more function, or not function actually, one more array. I will create one more array inside this function. And since I want to create one more array inside this function, I need to use this memory keyword. Why do I need to use this memory keyword? I need to use this memory keyword first because this array is a reference data type. Second, these reference data type references storage by default. So we need to tell to the compiler, to the Solidity programming language, that I need to create an array, and that array should be limited to this function call only. And for that, I need to use this memory keyword. So I will create one array. Let's say the name is ARR1. And in this ARR1, I will assign this ARR array that we have declared as a state variable. At this point of time, this ARR1 is a local variable, right? And this ARR1 is getting stored in this memory area because we have written this memory keyword. While this ARR is getting stored at storage area, okay? Because this is a state variable and it is declared at contract level. Now let's say after assigning this ARR to this ARR1, I want to change, let's say index value 0 of ARR1 to 90 like this, okay? So I can do this. Now in the same way, let's say I want to create one more function. Let's say function f storage. Okay. Again, it will be public. And in this, what I will do is I will again create one more array. But this array that I'm going to create will not be limited to this function. Means the array that I'm going to create will actually not be an array, but it will be a reference to this particular array. And you will understand this once we will complete this example. And since we want to reference this array, since we want to point out at this particular array, I need to use a keyword storage. So this storage keyword will actually help us to point out this array. So this storage keyword will actually help us to reference this ARR array. And how? So simply again we will have ARR2, okay, the variable name, and in this I will assign ARR. And let's say I want to change index value 0 of ARR2 to 90 here as well. And simply since we are actually changing, okay, there is some issue. Okay, I have made some mistake in the function spelling. Okay, so now if you will see, we have two functions here. First one fMemory, second one fStorage. And as I said, in this case, ARR2 is a pointer to ARR. Okay, so ARR2 is a pointer to ARR, and we can see that. While in this case, this ARR1 is a array, okay, is an array that we have created inside the memory. Okay, while this array, this ARR is actually created, this is also an array. I'm just telling, I know it might sound a little bit complicated at first, but trust me, after we will do certain examples, after we will complete our project, it will make sense to you. In this case, if you will see, this ARR that we have, right, this ARR is also an array. This is also an array that we have created at the storage area. Okay, so this is the difference. This is also an array. This is also an array. The only difference is that this array exists at this memory area, while this array exists at storage area. This is limited to your function, means this ARR1 is limited to your function call, while this is permanently stored at your blockchain. So now let us deploy this. Now let us see the difference between this storage keyword and memory keyword. So if you will see, we have this fMemory, and let me check the index value of 0 of this ARR, right? So it is 10, right? So it is 10. Now let me call this fMemory function. I will call this fMemory function here. Now, once I will call this fMemory function, you can clearly see that after the call, I am assigning this ARR to this ARR1, and then I'm changing the value of this ARR1. So now if I will call this fMemory, okay, so this change has been made to this ARR1 array. Now let me ask you one question, whether the changes that we are doing to this ARR1, whether those changes will be reflected to this ARR variable that we have created at the storage area. Like what I'm asking is that when we are changing the value of this ARR1 here, right, we are changing the index value at 0, whether those changes will also be reflected at this array or not. So you can think for a second and then you can again play me. So I hope you have paused me for a second. Now let me answer this question. And the answer to this question is no, because if I will call this ARR0, you will still see that it is still having 10 at index value 0. And it is also common sense, right? You will say that why it will change that, because this is a new array ARR1 and we are changing the array, this ARR1 array, not this ARR. So why it will actually reflect, like why the changes will be made to this ARR, right? And you are absolutely correct. But now let me call this fStorage function. Okay, I'm calling this fStorage function now. And this fStorage function is also doing the same thing. Like in this case, if you will see, we are assigning this ARR variable to this ARR2 variable, and then we are changing this ARR2 variable. But as I said that this ARR2 is not a new array, but this is a pointer to this ARR. So if now I will check the value of this ARR0, you will see that the value of ARR0 is changed, because this ARR2 is pointing to this ARR, and when we are changing ARR2, we are actually changing the ARR array. Now I know it is a little bit confusing, but let us see this with the help of our presentation. Now let us understand this with the help of an example. So when we created this ARR array inside our contract, then something like this actually happened at the contract level. Means at the storage area, this array was formed, this array was created. Now after some time, when we created this function by the name of fMemory, and when we declared this this ARR1 array, and then we assign this ARR inside this ARR1, in that case a new array was created, and this new array was actually got pointed by this ARR1 variable. So this is a new array, right? This is a new array that is created at the memory level. Okay, so this is created at the function level. And when we made changes to this ARR1 array, those changes got reflected in this ARR1 array. And this is what actually happened when we made changes to this ARR1 array. Those changes were not seen at this array, because this was an array that was created at contract area, at storage area. So this array did not get affected when we made changes to this ARR1 array, right? Because this is a new array inside our memory area. Now, when we did this by using this storage keyword, when we created a new function by the name of fStorage, and then we assigned this ARR to this ARR2 variable, this ARR2, as I said earlier, that it is not a new array. Actually, this ARR2 is nothing but this is a pointer to this array that we have created at the storage area. And when we made changes to this ARR2, right, like this, these changes got reflected at this particular place as well. And when we made changes to this ARR2 variable, the variable that is actually pointing to this array that we have created at contract level, those changes got reflected to this array at the contract area, at the storage level. So a new array was not created, and that's why when we made changes to this ARR2 variable, to this ARR2 array, those changes were reflected when we called this ARR0 index. Okay, and you can see that change here as well. You can see the difference here as well, that in this fStorage we are not using any keyword. Why? Because we are actually changing the state variable. We are actually changing this state variable when we are actually doing this ARR20 equal to 90, because now we are changing the storage area of this ARR array, right? While in the case of memory, while the case of this function, if you will see, since we are not actually touching the state variable, we are just viewing the state variable by having this ARR assigned to this ARR1, And when we are making changes to this ARR1, these changes are actually made to the new array, not to this array. And that's why we are using view keyword and no other keyword here. While in this case, since we are making changes to the array that is declared at contract level, at the storage level, that's why we are not using any of those keyword here. And this is a very important concept that you must know in Solidity, because this is something that we are going to use, that you are going to use a lot of time in Solidity programming language. So I hope by now you have understood the difference between these two arrays, like these two actually keywords, memory keyword and storage keyword. And if you have any doubts, you can comment below. I will happy to answer your queries. Thank you so much. Meet you soon in the next video. Now in this video, we are going to talk about struct data type in Solidity. So what is a struct data type? A struct data type is actually a complex data type. And what is a complex data type? A complex data type is usually a composite of other existing data types. So till now, whatever data types that we have seen so far were very simple data types, right? For example, if we talk about uint data type, it can only store uint elements. If we talk about arrays, so arrays can only store homogeneous element. But let's say I want to store the details of a student. Now, student can have multiple properties. For example, student will have its own roll number, his own name, or let's say his marks, or all different things are associated with a single student. Now, in cases like these, where we have multiple properties and all these properties are of different data types, we use struct. So for example, if I want to create a struct data type of a student, this is how it will look. So your struct, this is how you define struct data type. So struct student string name. So this will store the name of this student. uint roll, this will actually store the roll number of this student. And then you have this bool pass, which will actually store whether the student is pass or fail. And in memory, it will look something like this. So this single data type, if you will see, is representing all these three different properties, and all these three different properties are of different data types, right? Name is of string data type, roll number is of uint data type, and pass is of bool data type. So now if you want to store student details, we can easily store them with the help of using this struct data type. And how do we declare struct data type? So we declare struct data type like this. So struct type, then public, then var name. Again, public is totally optional, and this variable name, it's your choice. And struct type means, let's say I want to create a data type of this student type, then I will write student. Okay, so student public, and this will be your variable name. So like whenever you create a uint data type, your uint data type stores uint variables, right? Uint elements actually. So whenever you write uint public v1, so this v1 can store all the integer values. In the same way, when you are writing student public s1, this student data type can hold all these different values. And how it is? Let us see this on our remix ID. So now let us create one struct data type variable. Okay, so first of all, we need to define struct student, okay, and then the name of the student and roll number of the student, and in the same way, let's say the passing value of the student, whether the student is pass or fail. So if the student is pass, we will assign true, and otherwise if he is fail or she is fail, then we will assign false to it. Okay, now let's say I want to create the data type of this student struct, so I will write student, then public, and then let's say s1. Okay, now if I want to insert some element inside this struct data type, I need to create one function. Okay, insert, and in this I will assign the name. Sorry, the name will be in string type, right? So string, and again memory, because this is a reference data type, the name and uint roll number. So like this, and then we will have bool pass. Okay, and then since we are going to change the state variable, so we will not write view or pure, we will simply do curly braces. Now inside this, if you want to insert some element inside this, all these variables, I need to first of all point to this particular struct. Now what do I mean by that? Now first of all, instead of writing name is equal to name, okay, if you are going to write name equal to name, this will give you an error, because this name is nothing, right? This name is actually a part of this struct data type. So for that I need to use s1 dot name. So this S1 will actually help us in pointing this structure, and then we can easily assign the value to this name variable. So in this, when we created this S1 variable, this S1 variable started pointing towards this structure. And now when we are doing S1 dot name, so what we are trying to do is we are trying to use this S1 as a reference, and then we are assigning some value to this name variable. In the same way, when I want to assign some value to this role, I will write S1 dot role, and then I will assign some value to it. Okay. So this is how you can actually insert elements into your structure. So if you will go back, right, again, I have to insert the roll number as well. I will write S1 dot roll. Okay. And then the roll number that I will pass, and then S1 dot pass. In this, I will assign the value. Okay, like this. So in this way, you can insert elements inside your structure. And let's say if you want to return some elements, then you have to simply write function, then getter. Okay, and then you will write public. Since this is your state variable, you will write view returns. Let's say you want to return all the elements that are part of your structure. Then what you will do is you will write student. Okay, because your structure is of student type. And then you will write memory. Why memory? Because your struct is also a reference data type. So like we have studied in arrays and we have studied in strings, we have to do the same with struct data type as well. And then inside this, I can do return, and I can return the whole struct data type. Let us deploy this. Let us go down. So here, if you will see, I can insert some element. But before calling this insert, let me show you the initial value of all these variables. So if I will call S1, or if I will call getter also. So if you will see, by default, all the values are their initial by default values. Means if you will see, string is empty. Okay, that's why we have this empty. I do not know whether you are able to see or not. So let me zoom in a little bit. So you can see that this is empty. Then you have this 0. By default value of uint data type is 0. So that's why it is 0. And then you have this false. Okay. Let me zoom out again. Okay. Now in the same way, if you will call S1 also, you will see the same result. So name empty, roll number 0 and false. Okay. Now let's say I want to insert some element to this struct, right? So what I will do is I will write, let's say my name is Kshitij. So I will write Kshitij. I know it's a complicated name. And then let's say my roll number is 1 and I am pass. Okay. So I am pass. I will click on transact. Oh, this transaction is successful. Now I will call getter. And if you will see now, Kshitij 1 and true. And S1, if I will call again, Kshitij 1 and true. So this is how you can insert elements inside your structure. But there is also one more way with the help of which you can insert elements inside your structure. Because currently you can see that, let's say I have 10 elements here. So using like this particular syntax is a very tedious process, right? Again, I have to write S1 dot roll and like this, right? So it's a complicated process. So what I can do instead, instead of writing this whole thing, what I can do is I can write S1, okay, like this, and then equal to, and then I will use my student data type, and inside this I will do name, then roll number, and then pass. So you can do this as well. So this will also insert elements inside your structure. Okay, and let me show you this so that you can see that as well. So I'm again deploying this, and now if I will call S1 again, it will be totally empty. Now I want to insert some element. Again, I will do, let's say my channel name, so code editor. By this I will be able to do some brand promotion as well, and then let's say 2, and then I am again pass, and then I will call insert. So now this transaction is successful. Now I'm calling S1, so you can clearly see code editor, then the roll number 2, and then this is roll number is 2, and then it is pass, so that's why it is true. Okay, so this is how you can also insert elements inside your structure. And let's say if you want to return a particular value from your structure, let's say instead of getting the whole values, you want let's say only the name from your structure. In that case, what you will do is you will simply write S1 and the name, okay, of these values. So let's say I want to return the name, so I will write S1 dot name,
And definitely, since you are returning the name and this name is of string data type, right? It's a string data type. So you cannot use student memory here. Okay. So let me do this in a different function so that you are not confused. I will again create one function and let's say get name. And in this, I will again remove this. I will have string memory. Okay. And then I will write s1.name. Okay. So now by this function, you can return the name from this particular function. Okay. In the same way, if you want to return roll number, you will write s1.roll and then you have to change this data type to uint. And if you are returning a bool, then again, you have to change bool and then s1.pass. So in this way, you can create structures in Solidity. In this way, you can insert, get values from structures in Solidity. I hope you enjoyed this video. Meet you soon in the next video. Now in this video, we are going to see how we can create array of structures. So in the last video, we have seen how to create structures in Solidity, right? And in that example, in the last video, we have seen that this way we created this student type struct, right? And in order to use this struct, we created one data type, right? We created this data type of student like this by writing student and then public so that we can make this variable public and then s1, right? So by this, we were able to create this s1 variable which was able to store the value of a student, right? So this s1 can hold value of this student. But the problem in this approach is that s1 can only hold the data value of a single student. We cannot store the data value of multiple students. Let's say I want to store data values of 100 students. Now this s1 is not capable enough, right? Because this is a single variable and this single variable is only pointing to this particular struct. So how I can store values of 100 different students, or let's say more than 100 different students? Now in order to do that, we need to create array of struct. And how we can create array of struct? We have to simply write student, that is the data type, then 4. Let's say I want to store the data values of 4 students in the square brackets. Why? Because this is an array, right? And we have seen that, let's say if I want to create a uint data type array, I have to write uint, then the number of elements that I want to have, and then public, and then the variable name, right? If you remember. In the same way, I have created this student type array, okay, which will have 4 elements, and this 4 elements will be of student type, then public, and then s1. Now in memory, this will look something like this. So first of all, okay, let me remove this. So first of all, an array will be created, right? And since this is an array, it will have index number 0, 1, 2, and 3. And inside these arrays, what we can store? We can store the entire structure data. Isn't it amazing, right? So we can store the entire student data inside this array. So here I can write, let's say KSH. I can write max, so the data value of max. Here I can write the data value of, let's say, Raj, or like something like that only. Okay, XC, like something like that only. So by this, I'm able to store the data values of 4 students, and not only 4 students. Let's say if I want to store the data value of 100 students, so I can simply do student, then 100, and then public, and then s1, or whatever name that you want. Let's say student only. So you can do such type of thing in Solidity. Now let us see this with the help of an example on our Remix ID. So if you will see on your screen, we have the student struct. So first of all, we will create an array. Let's say I want to create an array of length 4, okay, and then public, and then s, okay, only s. Let's say for this, for like I want the name as s for this particular array. And let's say I want to insert some element inside this array. So what I can do is I can write function, then I can assign, okay, the name of the function, let's say insert student, okay, and inside this I will have index number so that I can tell that at which index I want which particular value, then the name of the student, so the same thing again, student name, then the roll number, and then our bool data type value. So I will make this public, and then I will simply have like this. Okay, since this is a string data type, we need to use memory keyword, right? Because this is a reference data type. And now inside this, in order to insert value inside this array, as we have seen also that how we can insert values inside an array, we have to simply write array and then square brackets. Inside this, I will have my index value.
okay, at which index I want the value to be inserted, then definitely equal to, and then as we have seen last time as well, so we will write student, and inside this I will pass the value as name, role, and then pass. Now by this I will be able to insert elements inside this student type array. And let's say if I want to return the value of a particular student, so function return student, okay, again I will have to have my index value, and then I can simply write public returns, and definitely I have to write view here as well, right? View, then returns, and since this will be returning the student type value only, right? So I will write student memory, right? Why student memory? Because this structure, if you will see this array, is actually pointing to this structure only, right? And we are actually returning an structure. So if we are returning a structure, we need to have student memory only, right? And then we will simply write return, and then we will have our array like this. Okay, I am missing one parenthesis, so let me have that. Okay, what is the issue here? Let me see. Okay, it should be returned. Okay, now everything is correct. So by this we can simply insert a value to this particular array, and we can return a value from this array. Let us check this. Let me deploy this. Let me go inside, and sorry, not side, actually scroll down, and then we have insert student. So let me have index value 0, let's say my name, and then roll number 1, then I'm pass again, and then I will transact. So now this transaction is successful. In the same way, let's say I hit index 1, I want some other value of, let's say, Raj, and roll number is 2, and he is failed, let's say, for example. Okay, I will again do transact, and let's say for second as well also we have some value, let's say Reena, then roll number is 3, then false, or let's say true. Let's make this true and transact. So now we have 3 values inside this array, okay, and we can check that as well. So I can simply go and I can insert my index value, then call. So you can clearly see it is returning the index value 0 array values, right? So Kshitij, 1 and true. In the same way for index 1, we have Raj, 2 and false. In the same way for 2, we have Reena, 3 and true. And definitely since third is totally empty, if I will call that, you will see that it is showing us the empty values, that is string is empty, then 0, and then false. Okay, so by this you can create your own array of structures, and you can insert values inside your own array of structures. So now this will give you a flexibility to store as many students details, or as many whatever details you want to store, complex details that you want to store inside this structure. And you can also make this array dynamic, so that, you know, currently it is not a dynamic array, right? You can make this array a dynamic array so that you can have as much value as you want inside this particular array. And how we can make this array dynamic? Simply we have to remove this index value right from this, and instead of this what we will do is we will write s dot push, right? Because for the dynamic array we use push, and in this way we can insert value inside this dynamic array. If you remember, right? If you do not remember this syntax, this push syntax, please go back to the dynamic array video. I have explained you that, right? So in dynamic array we can insert value by this, and we do not require an index value because push will automatically push the value at index 0, then 1, and then 2, and then 3. So like this you can also do the same, and let me show you this as well quickly. So let me deploy this. Again we have this, let me insert some value, let's say code editor once more, then 1, then true, and let me do transaction. So now it is successful, and we can check that as well, 0, and here you can see that code editor 1 and true. By this you can actually insert as many values inside this array, because now it is a dynamic array. Okay, now in this video we are going to talk about mapping. Mapping data type in Solidity deals with keys and values. So whenever you have to define a mapping in Solidity, this is how you define mapping. So you have your mapping from key to value. This key is nothing but the data type of your key, and this value is data type of your value. So let's say I want to store information of students. Let's say I want to store the name of students, and for every name that I'm going to store, I'm going to map it with their roll number. So in this case, this is how I will declare my mapping. So first of all, we will be having the data type of the roll number, which will be uint, right? Because roll number are numeric values. Then we will have string data type because we are going to store the name of students, right? So that's why string data type. So this mapping is from uint to string, and this is public. So definitely it is optional. And then we have this variable. And this is how it will look in our memory. So we will have a mapping. Okay. So I'm just showing that uint type roll number we are going to store, and string data type name we are going to store. So in this, we are going to store information like this. So we will have roll number, which is, let's say, 1, 5, 40, 50. And for every roll number, we are actually mapping it with their name. So 1 is mapped to Ravi, 5 mapped to John, 40 mapped to Alice, and so on. So this is how we are going to use this particular mapping, where you can clearly see this uint are these values. So these are the keys, and string are these names, and these are the values. Now let us see this on our remix ID. So let us create mapping, and this mapping will be from uint to string. Okay, sorry for that, string, right? And let me make this public and data. Now to insert some values inside this mapping, first of all, let me name the function as insert uint roll number and string memory name. Okay, and then it will be public function curly braces. Now in case of mapping, just like we insert values in an array, right? In the same way we insert values in a mapping. So data type is like, this is the variable, right? Data. So I will use this data variable. I will have my roll number inside it because this is the key, right? And then I will have my name like this, which is actually the value. And in this way, we can insert values inside mapping. So just like your array, right? So this is similar to your array, right? The only thing is that in this case, we write index value and then the value, right? The element, the data type of that, the element that we want to insert. Now let's say if I want to return from the mapping, so I will have return, or let's say getter function, and this I will pass the roll number, and then public view returns, and the value that we are going to return will be string value, right? Because the values are of string data type. So in this we will have string memory. Okay, and then I will do return data and then the roll number. So this is how it will return us with the name of that particular roll number. So the roll number that we have, the name that we have mapped with this roll number. So let me deploy this. I will click on deploy. Now we have insert data and getter function. So let me insert some value. Okay, so roll number, let's say, is 10, and let's say Raj is stored at roll number 10. So transact. Let's say at 100th roll number we have something like Reena. So transact. And let's say at 1000 of roll number, definitely it is not very much a possibility having a roll number like that, but let's say, so we have, let's say, Max, and then we can transact. Okay, now let's say I want to get the value. So either I can use this data variable because this is a public variable, so it is accessible to us, or otherwise we can use this getter function as well. So let me use my getter function because I have created it from scratch. So let's do that. And let's say I want to find the details of roll number 10. I will call. So now you can see that it has written this Raj. If I will have 100 and call Reena, and in the same way, sorry for that, Reena here. And then in the same way, when we have 1000 and I will call it again, you can clearly see it is Max, right? So this is how you use mapping inside Solidity. Now you must be thinking, are mappings and arrays the same thing? The answer to this question is no. Mappings and arrays are not the same thing. Definitely, syntax wise, if you will see, they look the same, right? Okay, this is how you store data into an array. This is how you access a data from an array. So syntax wise, it might look same, but mappings are very, very, very much different from arrays. And let us see this and let us understand this. Now let us understand the difference between mapping and array. So this is how our mapping looks like, right? So let's say we have roll number 1. At roll number 1, we have stored this name, 2, John, and the same way we have all the names, and all these names are mapped to a roll number. So this is how we create a mapping, right? Now if I want to do the same thing with this array, then how it will look? Okay, then how it will look inside our memory. So let us see that. So if I will do the same thing inside an array, it will look something like this. Because as you are storing at index 1, we are having the name Ravi. At index 2, we are having the name John, 4, Alice, and at 7, we have Akash. So one thing to notice here is that if we are doing the same thing like we have done with mapping, in mapping you will see that there are no empty slots, right? There are no empty slots. While to do the same thing with an array, it has a lot of empty slots. And the reason is very simple, because in mapping, if you will see at 1, we are not actually storing roll number in a continuous fashion, right? We are storing roll number in a discontinuous fashion. So at 1, then 2, then 4 and 7. So there is no continuity here, right? While for mapping, as we all know that mapping, or sorry, actually array, while in array, everything is actually stored in a contiguous fashion, in a continuous fashion. So that's why we have so many empty slots. And all these empty slots are actually getting wasted, right? Now just think, in order to store 4 values in an array, I have to create an array of size 8, right? Because the highest index value is 7. So I have to create an array of size 8. And in those size 8 array, various slots are getting wasted. 4 slots are getting wasted. While if we do the same in mapping, if you will clearly see, mapping, we are not actually wasting any kind of slot, because mapping is actually working on hash kind of data structure. Okay, so like if you have studied dictionary in Python, right? So mapping are working just like the same, and mapping are much faster than array because they are not storing data in a continuous fashion. They are storing data randomly. Okay, and that's how mapping are different than array. So which to use, when to use, depends upon whether you want to store continuous data or whether you want to store discontinuous data. So if you want to store continuous data, in that case array will be the best choice. But if you want to store data in a discontinuous manner, then mapping will be the best choice. And other difference between mapping and array is that mapping are not iterable. You cannot run loops on mapping. But in case of array, arrays are iterable and you can run loops on an array. So this is how mapping and arrays are two different data structures, and you have to use them according to the need, according to the use. So remember these 2 points. Mapping stores data in non-contiguous fashion, while arrays store data in contiguous fashion. Mappings are not iterable, while arrays are iterable. So I hope by now the concept of mapping as well as what is the difference between mapping and array are clear, and we will meet soon in the next video. Now in this video we are going to talk about mapping with struct. So let's say I want to map struct data type using a mapping. So let's say I want to map roll number of students with a lot of student details. Like in the previous video, we were just storing the name of the student, right? So for every roll number, there was a name associated with it, right? But let's say I want to store the details of a student. Let's say the name, roll number, and pass. Pass means as whether he's pass or not. Now in this case, you can clearly see that I need to use a mapping. So in this video, we are going to see how we can map, okay? How we can map from UINT or any other data type to a struct data type. So let's say I have created this mapping. So when we will do this, something like this will happen in memory. I'm just taking some random value here, 0, 12, and 100, because mapping does not store data in a contiguous fashion. So 0, 12, and 100. And at 0, 12, and 100, I want to store details of students. So this is how it will look like. So you can clearly see that at 0th index of this mapping, I'm storing the details of this student. At 12th index of this mapping, I'm storing the details of this student, and so on. So here I can store the value, means the details of Raj. Here I can store the details of Max, and here I can store the details of Reena, right? So in this way I can do that. So this is how we actually, as I said, map from UINT, or definitely you can have any other data type as well, to student, means that which is actually a struct data type. Now let us see this on our remix ID. So now let us create one struct. Let's say this is student, and then we will have the name, right? The roll number, as well as whether he is pass or fail. Okay. Now I will create a mapping for this. Okay. So UINT, then to student, and let me make this public, and then data. To insert it, I have to simply make a function insert. In this, I have to pass the index value. So UINT index, So just like your array, right? If you remember. But again, arrays and mapping are two different things, right? We have seen that in the previous video. So string, memory, name, then uint, roll number, and then we will have bool, then pass. Okay. Then we will have public, and then we can simply use our data variable and insert, sorry, not insert actually, index. And in this, we will use our student data type. For that, we will have name, roll number, as well as the passing value. Okay. Now, again, if you want to return something, so return value function. And in this, again, we will have the index value. Okay, let me make it index. Then again, public view returns, and in this now we will have the value. So the value, if you will see, this is the whole structure, right? So if you want to return the whole structure, you will have student memory, right? Memory, and then you will return data index. So this is how you can return a value, and this is how you can insert a value in this mapping of structs, basically when you are using struct in mapping. So now if you want to insert something, you can clearly have your index value, let's say 9. At 9 I want to store the data of Raj, and roll number is, let's say, 1. And let's say, and definitely you can also, I have used a different index. You can also use this roll number as your index, so that's up to you. Okay, so you, instead of having a different index number and a different roll number, you can choose the same thing as a roll number as well as the same variable on both the places, right? You can do that as well. And let's say he's fail. Okay, and transact. And if you want to see this, just go and write 9 and click on this. Definitely I have called this variable. So Raj, roll number 1, and true. In the same way, if you will do the same with your function, it will return the values, right? So this is how you can use mapping with struct, and this is a very important data type, because this data type you are going to see a lot of time whenever you are going to create Solidity projects. In our Solidity project as well, we are going to use this type of data structure. Okay, so understand this data structure very well, because we are going to use this a lot in our Solidity project. So I hope you enjoyed this video. Meet you soon in the next video. Now in this video, we are going to talk about nested mapping. And let me tell you, nested mapping is a very important thing to know, because this is also something that you are going to use a lot in Solidity projects. Okay, so understand this data type in a very important way, in a very well way, I will say, because it is very important. Okay, so in order to declare nested mapping in Solidity, this is how you declare a nested mapping in Solidity. A mapping, so this is your first mapping and this is your second mapping inside your this first mapping, right? That's why we call it as a nested mapping. Now I know you must be thinking, okay, this is so complicated, but don't worry, I'm going to tell you a trick with the help of which it will become very easy. Okay, so in this case, if you will see, we have this key. Definitely key can be anything. I'm just using address data type here, but your key can be anything. Any data type here can be any data type. Here can be uint or a string data type. Anything can be here. But we are going to understand the concept of nested data type, so I'm just using address here. In the same way, this is your second mapping, and in this also you have this key. Okay, and this is your bool. So for this mapping, this is the key and this is the value. For this mapping, first mapping, this is the key and this entire thing is the value. But again, I know it might sound so complicated, but trust me, I will make it very easy. First of all, let me remove all these things so that we can have a clear picture of it. Now let me tell you the trick. So whenever you are creating a nested mapping, or whenever you are seeing a nested mapping, just imagine this nested mapping as a two-dimensional array. I hope you are familiar with the concept of two-dimensional array. This is a very common data type that we have in all the programming languages, be it C, Java, or any other programming language. And you have to imagine this nested mapping just like that two-dimensional array. So this is how a two-dimensional array looks like. So here you can see that I have 3 slots, 3 rows and 3 columns. So these are the 3 rows, 1 row, second row and third row, first column, second column and the third column. I'm having a limited size of slot. Definitely in mapping, you can have as many values as you want. But as I said, I want you to just imagine this nested mapping like a 2D array. It can be as long as you want. Okay, but for demonstration purpose, I'm using a 3x3 dimensional, two-dimensional array. Okay, now imagine this first data type, this first key, right, written at this site like this. Okay, so this address 1 and address 2 and address 3 that you're seeing are actually the key value of this mapping. So for this mapping, okay, so all these things in green, okay, so this green thing that you are seeing is actually the key value of this mapping. Now on this column side, imagine the key value of this mapping. So with this blue color, address 1, address 2 and address 3. So this with this blue color that you are seeing, so this with this blue color, these are the key values of this mapping. Okay, I have colored this with blue and this is with green because the key value of, like, I'm demonstrating this key value as green color and for this key value as blue color. Now let's say you want to insert some element inside this mapping. How you will do that? It's very simple. Let's say if you want to store some value at this position, okay, at this position. So how you can reach to this position? First of all, you will go to address 1, right, like this. So first of all, you will go to this row, this address 1 row, and then you will go to this address 1 column, right? This is how you can, you can see a intersection, right, like this. So like address 1 and address 1 like this, right? So intersection point is this. So this is how you can actually insert value into this slot. First of all, you need to reach that slot and then you can insert values in that slot. So if you have to do the same for, let's say, address 1 and address 2, let's say address 1 and address 2, you can clearly see this is address 1 and this is address 2. And let's say you want to store some value true because your value is of Bool type, right? This value is of Bool type. And by doing this, what you are doing is you are actually inserting true at address 1 and address 2. This is how you can insert element inside a 2D mapping. Let me remove all these things first of all. Now in the same way, let's say you want to insert some value at address 2 and address 3, means check is the variable name. If you will see, check address 2. So just like your 2D array, you are inserting the values address 2 and address 3. So address 2, again, you have to go to this row and then address 3, that is this particular column. So you will insert value here. In the same way, if you want to insert value at address 3 and address 1, so this is your address 3 and this is your address 1. So the value will be inserted here. So this is how you can insert values inside your nested mapping. And this is also how you can fetch values from your nested mapping by just writing return, right? And simply doing the variable name, this variable name, check, and then the value of this row, which is actually the key value of this particular mapping, right? Address 1 like this, right? And then again address 2, and you can, in the same way, you can, in the same fashion, you can return the entire value, that is true, false, whatever. Let's say if you want to store value at address 1 and address 3, means at this particular location. So you have to simply do address 1 first of all, and then address 3, and in this way you can insert value at this position. Okay, now let us see this on our remix ID. So as I said, you can have anything as your data type. So we can also have uint data type as well. Okay, let's do that only so that we can create a mapping like this as well, so that I can show you. And let's say again, since this is a nested mapping, so again I will have one more mapping, and let's say again I have uint, and in this position I'm using some Bool data type, means I'm storing Bool data type values. So again I can make this public and I can have my data field like this. So let's say I want to insert some values to this mapping. What I can do is I can create one function, and as I said, in order to insert you need two values as in for this row, right? This will be your row and this will be your column. So I can write, let's say, row, and I can write column. This is just I'm writing like this. Definitely you can use anything, whatever you want, but we are going to use this nested mapping in our project as well, so it will get more clear when we will do our project. Okay, if you are not you are not understanding the application of it, then you will understand the application of this mapping as well. So public, and now I will have data, and in data, first of all I will have my row, and then I will have my column. Okay, like this. And then whatever data I want to insert, definitely it will be of Bool data type. So I will have to have a Bool value here. So value, and in this I will insert value like this. In the same way, I want to, let's say, return something from this, then I can do function return value. Okay, in this again I have to have my row, my column, right? And then public view returns, and the value that will be returned will be of Bool type, right? So I will have Bool here, and then I can simply return the data row and then the column. It is easy, right? It is very easy. And let's deploy this. So now you can clearly see I have my insert field. I will mention the row number. Let's say the row number is 0 and the column number is also 0. And in this I want to store true. I can transact. So now you can see that it is inserted. In the same way, let at row number 0 and column number 1 means at this position. So this is row number 0. Okay, I am considering this as row number 0. And definitely this 1, 2, 3 I have written, but you can consider it as 0 only. So this is your row number 0, and at column number 0 you have inserted what? You have inserted true, right? So let me write it down with pen so that we are clear with this. In the same way, let's say I want to store some value at 0th row and first column. So this is the 0th row and this is the first column. So I want to store, let's say here, let's say false, for example. So I can do that, right? How? I will simply go and write false here, and this is how we can transact it. And we can check the value as well by going to the return value function. I can do 0 and I can do 0. So you can see that this is true. Again at 0 and 1, this is false, right? And if you are going to check it for any other position, it will be by default false only. Why? Because by default Bool data type values are false if you are not going to initialize them. So that's why it is showing us false. Okay, so you can clearly see that nested mappings are very easy in nature. Definitely the only part that you have to imagine is that they are like a 2D array. Okay, so I just imagine it like a 2D array, and I just insert value inside this 2D array. Okay, so I hope you enjoyed this video. Meet you soon in the next video. Now in this video we are going to talk about mapping with array, and let us understand this with the help of an example. So let's say there is a student who wants to store his marks. Okay, so this student has a address, has a he can have any kind of address, he or she can have any kind of address, and this address wants to store some this address wants to store his or her marks. And let's say there are various subjects, and if there are various subjects, then definitely we need a array kind of structure which can hold all the marks of that particular student. Now in scenarios like this, what we can do is we can declare a mapping. So here if you will see, we have a mapping which is from this address type to this UID type. This UID type will be used to store the marks, and this is a dynamic kind of array. Definitely you can have a fixed kind of array as well. And this is the address data type. Again, you can have any other data type as well, but for the example I'm taking address to UID type dynamic array. And then we have this private visibility specifier. Definitely you can have public as well, it's your choice. And then we have this variable by the name of marks. Now how the values will be stored inside this mapping, let us see this. We will have something like this, where we will have some addresses, and all these addresses are actually storing their marks. So let's say this ABC has this array 10, 20, 30, 40, 50. So these are the marks of ABC. Then we have DEF, which is storing 1, 2, 3 as his marks, 121, 2, 3F, and all these addresses, as you can see, have their own marks, right? Definitely, let's say that this is a dynamic array. That's why it is an uneven structure, because this is the dynamic array, right? So let's say this student has scored in physics, chemistry, maths, and let's say any other subject like English or Hindi 10, 20, 30, 40, 50, and then we have 1, 2, 3 or like this. Okay, so this is how it will look inside our memory. And let's say I want to store this particular value. So how we can access this particular value? Now in order to access this particular value, what we have to do is we have to simply write marks, okay, which is actually the variable. Then we will have like which address you want to access, which is actually 0 DEF, right? 0 DEF. And after accessing this means this particular thing will start pointing towards this. And let's say I want to access this. So this is 0 index, this is first index, and this is second index, right? So I want to access this particular index. How we can do that? We have to simply write, since this is an array, right? We are pointing towards an array. So we have to write 1 here. Okay. And by this, we can access this particular data. Okay. Let me give you another example as well. Let's say I want to access this particular data. So again, first of all, you will have your variable name, that is marks. Then inside this, you will have your address, which is 0x73E, right? So this will start pointing towards this, right? This array. And now I want to access this particular data. So this is 0, this is 1, this is 2, and this is 3, and this is 4.
So now if I have to access this, I have to simply write again another square bracket because this is an array, right? This is an array. So I will have 3 here. Now by this, I will be able to point towards this data. Now let us see this with the help of our Solidity programming language. So now inside this contract, I want to create my mapping. So I will do this, then the address, and then I will have my array, right? And then let's say I want to make this public. So I will make it public and then marks. Okay. Now I will create one function in order to insert some of the, I want to insert some of the marks to this particular address. So insert marks, and this function will take an argument of address type so that it can store the address inside the mapping, and then we can access that particular array of that particular address, right, on inside this mapping, as we have seen in the PPT as well. So we will have the address here. Okay, then let me make this public and like this. So now in order to store some value inside this array, first of all I have to reach to that array, and how I can do that, I can simply do marks and then I will write the address. Now I am pointing towards a array, right? So let me go back to our slide. So now I am pointing towards an array, right? Any array it can be, whatever address we will point means whatever address we will pass inside it, like this. So that particular array will get pointed out, right? And now what I will do is I will do dot push. Why dot push? Because this is a dynamic array, right? We are pointing towards a dynamic array. So let me have one more element. Let's say that is marks. And then I will simply insert the marks inside this array. And now let's say I want to return data from this mapping. So what I will do is return marks, and then I will do it public returns. Now I will do return. Now I want to ask from you, you can pause me for a second. Now let's say if I'm passing marks and here I am passing address. Okay, and let me have this address here. Okay, now I want to ask from you what will be here, what we have to write in this small bracket. Think upon a second and let me know. I hope you have thought upon it, and let me tell you what we will have inside this returns statement. We will have uint and then dynamic array and then memory. Why? Because this is returning an array, right? This is pointing towards a dynamic array. That's why uint memory. And let me have view here. Now let us deploy this. Now let me insert some value. So inside this, I will have this address, let's say. Okay, I will paste this address. I will have 10 here. Then let's say 20 here. And let's say 30 here. Okay. Let me have some other address. Let's say this address. Let me copy this down. Let me paste this here. And now let me have 1 and then 2. Okay. Now let us see this. So I will copy this address and I will paste it inside our return marks function. You can do this like by calling this as well. This marks, this particular marks mapping, where you can clearly see that it is asking for the address as well as the index you want to access, and we will see that as well. Let me show you that as well. But for now, let me call this return marks. So now as soon as I have called this return marks, it has returned the marks of this particular address, right? 1 and 2. In the same way, if I will go back and I will copy this particular address and I will paste it here, return marks, so 10, 20 and 30, right? And you can do the same as well with this marks variable, because this is a public variable, right? So I will provide the address. Okay, so this is the address of this particular thing, 05B3, and let's say I want to access this 20. So 20 is at first index, right? So I will type 1 and I will call. So you can clearly see that it is returning 20. So if I will do 2, which is index 2, so it will return 30 because 0, 1 and 2. Okay, so this is how we use mapping with arrays in Solidity. Now in this video, we are going to talk about global variables in Solidity. Global variables in Solidity makes the life of a Solidity developer very easy. So Solidity provides us with some variables like these, which are very helpful for writing Solidity code. So for example, block hash, which returns the latest block number. So here you can see that hash of the given block when block number is one of the 256 most recent blocks, otherwise returns 0. Okay. Then we have this block.base fees, block.chain ID, and we have so many different global variables. Some of these global variables are very useful, like block.timestamp, message.sender, and message.value, and we will talk about these global variables, okay, in this video. And definitely, if you want to check out all these different variables, you can try it by your own.
But let me show you how we can use these three different global variables. So let me first of all show you how to use this message.sender. So let me create one function, for example, okay, and let me have this call by address, okay, or let me not have this name, otherwise it will confuse so many different people. So let me have, for example, caller address, okay. So this function is going to return the address of the person who is going to call it. So let me do that. Public view returns, and this will be address because this is going to return some address. So we want to have the address of the caller, means whosoever is going to call this function, I want the address of that particular person. So in order to access that address, what I have to do is I have to write return message.sender. Now this message.sender will return us with the person, or I will say this message.sender will return the address of the person who is actually calling this function, and we can check that. So for now, let me give you an example. For example, let me give you an example in order to better understand it. So in this, if you will see, currently we have this account list, right? And I have selected this particular address, and I'm going to use this address in order to call this function. So I'm going to, okay, let me delete these previous contracts. Now deploy it. So now I'm going to call this function. So if I will call this function, you can clearly see that since I have selected this address in order to call this function, that's why this return this particular address. Okay. So if I will change this address, let's say to some other address, AB8, and now I'm calling this function. So you can clearly see that message.sender is actually holding the address of the person who is actually calling, right, which is actually 0AB8, because this is the person who has called this caller address function. In the same way, let's say if I have selected this particular address and if I have called this now, so you can clearly see that now it is returning us the address of this particular person. So message.sender is actually returning the address of the person who is actually calling this particular function. And this is a very useful global variable which you are going to use a lot in your smart contract. But for now, I hope you have understood the concept behind message.sender. You can read this in this as well. So message.sender, sender of the message. So when it's saying sender of the message, it's actually the caller of the function, okay, in a much more easy way. Now let me show you another another global variable, and that global variable is block.timestamp, which actually returns the current block timestamp. So return block timestamp. So let me again have public here, view returns, and this will be in uint, and then it will return block.timestamp. Now why I have this uint? Because block.timestamp will be a uint type data, so that's why uint. Okay, let me deploy this, and let me call this return block timestamp. So you can see that it has returned us with this timestamp, right? And this timestamp is nothing but this is Unix timestamp. So Unix clock is running since 1st January 1970. Okay, that is a 1 second clock which is ticking every second, and that's why we have this weird kind of timestamp. And we can convert this if we want to. We can go and copy this timestamp. We can go to this unixtimestamp.com and we can enter our timestamp. So currently, if you will see, this is the timestamp which is actually taking for every 1 second, and this clock is running since January 1, 1970. And if I will convert my timestamp, which I have copied right now, I will convert it. So when I'm converting it, you can clearly see that. So this is my time zone. I am living in India. So I will show you this Tuesday, January 3, 2023. Okay. And this is the time at which we have actually, deployed at which we have actually, created this block. So this is the timestamp of this particular block, like when this transaction is successful and the block is created. Okay. And that's what we are seeing here as well. So this is the time in our time zone, right? And we will talk about the third global variable, that is message.value, in the next video when we will talk about payable addresses and payable function, because then only you are going to understand the concept of this message.value in a much more better way. Okay. Now in this video, we are going to talk about payable keyword in Solidity. So let's say I want to transfer some ether to my contract. I want to do that. Okay. And if you remember from our Ethereum types of accounts video, I told you, right, that contracts have their own account, And these contracts can also receive ether. And this is what we are going to see today as well. Okay. So let me show you that. So let's say I want to transfer some ether to my contract. So I will do function and then send ether to contract. Okay. This is the name of my function. And then I will make it public. And now in order to receive some ether in my contract, I need to make this function a payable function. Okay. So I will use this payable keyword and then I will have my parenthesis. And this is it. So now my contract, or I will say this function, is ready to accept ether, and whatever ether will be transferred using this function will get automatically transferred to our contract address. And we can see that as well. So let me deploy this for now. So once I will deploy this, you can see here that this is my contract address. Okay. So this is our contract account. And currently the balance of our contract account is 0 ETH, right? It is showing us 0 ether, right? Now I want to transfer some ether from, let's say, this account to this particular contract. So how can I do that? So in order to do that, I have to simply write some value here in this box, this text box. Let's say I want to transfer 10 ether to my contract. So I will have 10 here. Then I will select unit as ether. And now what I will do is I will simply call this send ether function. Now, as soon as I will call this send ether function, 10 ether will get deducted from this account, because this function is going to call this send ether to contract function. And he has selected 10 ether, right? So 10 ether will get deducted from this account and 10 ether will be transferred to our contract account, which is this address. So let us see this. So I'm clicking on this send ether function. So now you can clearly see that the balance of our contract is 10 ether. And if you will go back, you can clearly see that earlier this address was having around 99.99 ether, and now it is only having 89.99 ether because 10 ether has been deducted from this account address. So this is the use of payable keyword. Okay. And it is not like, you can definitely write some code inside this as well. It's not that you do not need to write any kind of code inside this. You can have whatever code you want inside this function, but in order to receive some ether, you do not need to do anything. Like just doing this is more than enough in order to have your contract capable enough to receive some ether. Okay. But definitely you can write some code here. Like let's say you want to add some number, you can do that. That's not a problem. It will not give you any kind of error. That's not an issue. But yes, in order to receive ether, writing this is more than enough. Just writing this payable keyword will make your contract powerful enough to receive ether. And let us see one more thing also. Let's say I want to see the balance of my contract. Definitely I can see this as like here as well, I know. But let's say I want to do it from my end. So what I can do in order to do that is balance of contract. Okay. And I will simply then make it public, view, returns. And since the balance of my contract will be in uint, so uint. And then I will have return. And now in order to fetch the balance of my contract, what I have to do is I have to write address, then this, okay, and then balance. Now this syntax will actually return the address of, sorry, not the address, actually the balance of my contract. Okay. So this is a convention, like I will say that this is actually this that we are using here, right? This is actually representing our contract. Okay. And then we are actually explicitly typecasting it to a address type. Okay. And then we are fetching the balance by using this dot balance method. So let me show you this. So let me deploy this again. Okay. So now if I will see the initial balance of my contract, it is 0. Okay. Now let's say I want to transfer some ether to this contract. Let's say 20 ether this time. I will click on send ether. So now the contract is having 20 ether. And now I will check the balance. So now you can see that 20 ether has been transferred to my contract account. It is not showing in terms of ether, actually. It is showing in terms of way. That's why it is a huge value. And I can prove that as well. Let me show you ether to way converter. Now I will click on this, and now let me have this value. So now you can clearly see that after having this value, it's get converted to 20 ether, right? So whenever you are actually doing some transaction in Solidity, right, most of those transactions are being done in way only. For us, we are seeing it in ether, but at the backend, whatever transaction that we are doing is actually in terms of way. That's why it is showing us this way value. Okay, so by using this payable keyword, you can transfer ether to your contract, and by using this particular syntax, you can get the balance of your contract. Okay, so this is it for this video. Meet you soon in the next video. Now, in this video, we are going to talk about payable addresses in Solidity. So in the previous video, we have seen how to make a contract payable in nature, right? Whenever we make a function payable in nature, then we can receive ether to our contract address. And in this video, we are going to see how we can transfer ether to some externally owned account. In the last video, we have transferred ether to contract account. And in this video, we are going to transfer it to a EOA account. So let us create one function in order to do that. So I will create one more function, send eth, okay. And in this, I will provide the address of the receiver, okay. And then I will make this public. And then I will have my curly braces, and inside this I'm going to transfer ether to this particular address. Now, in order to transfer ether to this particular address, I need to make this receiver address a payable address. Otherwise, this receiver address will not be capable enough to receive ether or to transfer ether. So let's say if I will do receive okay, dot transfer. So this is the method by which we are going to transfer ether to our receiver address. And inside this, I will have message.value. So if you remember from our global variable lecture, I told you, right, that we will talk about message.value in our payable video. So now we are going to talk about this message.value. So I will tell you what is this message.value. But for now, if you will see, we are actually having one error. And the error is that receiver address cannot use send or transfer function. So send and transfer function are only available for objects of type address payable, not address. So what this warning is actually saying, what this error is actually saying is that your receiver address is not capable enough to receive ether or to transfer ether, let's say. Okay, in both the cases, this receiver is not capable enough. Now, in order to make this receiver capable enough, I need to use payable keyword with this receiver. So now once I have used this payable keyword with this receiver, now you can see that there are no errors. Now we have a different kind of error, that is that if you are using message.value, okay, so you will see that message.value can only be used in payable public function. So if I want to use this message.value global variable inside this function, I need to make this function payable, okay. But this again, I will say, when I'm going to call this sendeth function, it will transfer ether to this receiver address, and we can see that. So let's say I will select this address as my receiver, okay, and this address is going to transfer some ether to this receiver address. So let's say I have selected 10 here, okay, so 10 ether will be transferred to my receiver address. So if you will see receiver address, currently it is having 99.99 ether. Once this function will be called, so 10 ether will get deducted from this account and will be transferred to this account. So now I have this 10 value here, and this 10 value, whatever value I'm going to write here, this value will be here, okay. So if I'm going to write 20, so this message.value will be having 20. So like message.sender, right, if you remember, whatever value we have here, message.sender will be having that particular value. In the same way, whatever value we will have here, message.value will have that particular value. So now what I'm going to do is, okay, let me delete this previous account. Okay, no, that was not the previous account, right? Okay, let me deploy this once more so that we have no confusion. Let me deploy this. Okay, so now we have this new contract, and now I'm going to transfer some ether to this particular account. Okay, so now I'm going to click on this sendeth function. So this transaction is successful, and now when I will see this account, you can clearly see that 10 ether is deducted from this account and 10 ether has been transferred to this particular account. Okay, so this is how you actually transfer ether from one address to another address. This message.value, as I said, is the value. Whatever value you are going to have here, that value will be in this message.value, and we can check that as well. Let me have, let's say, 50 ether here. Okay, so I'm taking all the balance of this account and I'm going to transfer it to this account. Let's say I'm going to copy this, I'm going to paste this here, I will send it. So this transaction is successful. So if you will see, now it is having only 9.99 ether, and this account is now having 150 ether. Okay, So this is how we actually transfer Ether from one address to another address. So remember that whenever you want your address to receive or send Ether, you have to make your address a payable address. Okay. So this is something you have to remember. So I hope you enjoyed this video. Meet you soon in the next video. Hi everyone, welcome back to Code Eater. In today's tutorial, we are going to see Lottery Smart Contract project. So as we have discussed in our lottery, or I will say in our Solidity tutorial, that we are going to do 3 projects, right? And the 3 projects are lottery project, second one crowdfunding project, and the third one event organization project. And in today's video, we are going to start with lottery project, where we are going to create our lottery smart contract from scratch. Okay. And what are the prerequisites of this particular video? The only prerequisite of this video is that you should know Solidity. And if you do not know Solidity programming language, then I will advise you to watch my Solidity tutorial, where I have uploaded around 33 videos on Solidity programming languages. Okay, the link will be shared in the description, or I will share in the I button. And before understanding how to create this lottery smart contract, let me tell you one more important thing, that we are not only going to create this smart contract from scratch, but we are also going to deploy this smart contract on the Ethereum blockchain. And for the deployment, we are going to use GoRally test network. We are going to use MetaMask wallet. We are going to use Faucet. I know these jargons, these technical words that I'm using, you might be confused, but I'm going to cover all these things in this particular project as well. So we will create it from scratch, and then we are going to deploy this on the blockchain. So let's start. So now let us understand what our lottery smart contract actually does. Okay, we need to understand the algorithm before implementing our lottery smart contract. So in our lottery smart contract, we will have 2 entities. First one, our manager, who will be controlling, or I will say who will be managing this whole lottery smart contract. And then we will have some players who will be participating inside, like I will say, who will be participating into this lottery. And as we know from the concept of lottery, that there are various people who are participating into lottery, and only one of those people, or I will say person, wins that particular lottery, right? So if there are 10 people, only one of them will be the winner of this lottery, right? And we are going to do the same in this lottery smart contract as well. Now, in order to participate into this lottery, this player person need to provide some amount of fees. And for assumption, like we are taking that the participation fees will be 1 Ether. So if this player wants to participate into this lottery, then he need to donate, or I will say he need to send 1 Ether to this lottery smart contract. And how he will call this lottery smart contract? He will call this lottery smart contract using this participate function that we are going to create. So he will call this participate function, and then he will send this 1 Ether to this lottery smart contract. And the second assumption that we are going to take is that in order to run this lottery, let's say this manager want to declare the result of this lottery, in that case, there must be at least 3 participants in this lottery. So if there are greater than or equal to 3 participants who have actually participated into this lottery, then only manager will be able to decide the winner. Otherwise, he won't be able to decide the winner. So let's say there are 2 more people who have participated into this lottery. Since they have also participated in this lottery, they will be also sending their ethers to this lottery smart contract. So for now, you can clearly see that this smart contract is holding 3 ethers, right? Because each of them have sent 1 Ether to this contract, right? Now, once we have 3 people here, okay, so this is the only condition that we have, that the participant should be greater than or equal to 3. In that case, manager will be able to call the pick winner function that we will be creating inside this lottery smart contract. Now, once this manager will call this pick winner function, a random person will be selected from these players, and we are going to implement that function as well in this lottery smart contract. So he will call this pick winner function, and a person will be randomly selected from these players. So let's say this person got selected, and once he will get selected, all the 3 ethers will get transferred to his or her account. So this is how we implement our lottery smart contract. Okay, so this is the algorithm, and now it is the time to create our lottery smart contract from scratch. Now let us start with the development of our lottery smart contract. Let me zoom in a little bit. Okay. Now in this lottery smart contract, first we will develop all the entities that are going to participate in this lottery smart contract. So the entities that will be participating, as we have discussed, will be manager, right? Players and winner. Okay. So let me declare some state variables. First, we will have the address of the manager. Let me make it public for now. Definitely, it is up to you if you want to make it private or internal. Definitely, you can do that as well. But I'm making it public. Then we will have the address of our players. And so as we can have many players, right? Like there can be 2 people, there can be 3 people, or there can be more than 3 people, right? So for that, we require to have a dynamic kind of array. And this dynamic kind of array will be payable in nature, because as we have discussed, right, in the payable address section, that whenever an address wants to receive or transfer ether, in that case, that address need to be payable in nature. And that's why this array will also be payable in nature, so that the players can send and receive ethers. And then we will have address of our winner, and this will also be payable in nature, because winner will be the one who will be receiving the lottery, the lottery reward, right, at the end of the day. So that's why it will be payable in nature. So it will be winner. And now during the time of deployment, I will set the manager of the contract. And for that, I will create a constructor. And during the constructor only, I will have my manager address. And inside this, I will put this message.sender. Now, why I'm doing this? Because during deployment, our constructor function will get run. We have discussed about this as well. So during deployment, this constructor function will get run. And as soon as it will run, whosoever will be deploying this smart contract, that address will get stored inside our manager address. Okay. So that's why we are having it inside a constructor. Now, in order to participate into this lottery, we need a function, right? We need a function through which players can participate. And for that, we will create one more function by the name of participate. And inside this, we will have payable. Again, it will be payable in nature, because the players are going to spend some money, right? They are going to spend some money in order to participate into this lottery. So we need to make this participate function payable, so that whenever a player is participating into this lottery, they need to send some amount of ether, and this ether will get transferred to our contract balance. So let me check it actually in the starting only, whether the message.value means the ether that is sent by the players, that are actually sent by the players, is equal to 1 ether or not. So we are here taking that in order to participate into this lottery, player need to submit around 1 ether. It's up to you if you think, okay, no, player need to have some less amount of money or more amount of money. Definitely you can do that. Okay. And then we will have, okay, if this is not true, means if this particular expression is not true, in that case, we will throw an error that please pay 1 ether only. Okay, like this. And if this condition is true, means if this thing evaluates to true, in that case, what we will do, we will simply push the players into the players array, right? So you will see this is the players array, right? And I'm going to push the message.sender. And again, we need to make this message.sender a payable message.sender, because this message.sender is a normal address, and this normal address need to be converted into a payable address. So that's why now this message.sender will be in a position to accept and receive ether. Okay, so this will be our participate function. And in order to check, let's say if the manager want to check, like, okay, whether how much ether till now the contract has so far, like how many people have participated into this lottery. So what he can do is he can call this get balance function, and he and or she, okay, not only he, manager can be anyone. So yes, get balance, public, view, then returns. So this will return the balance of our contract. So it will be in uint. And then we will make one more condition check, that manager should be the one who will be calling this particular function, not anyone. Okay. Again, this is a restriction that I want in my contract. If you think, okay, I do not want to restrict it to manager only, you can definitely give access to anyone by not having any kind of require statement. And then if this is evaluates to fall, we are going to send that you are not the manager. Okay. And then we are going to return the balance of our contract by doing address.this balance. And we have talked about all these things. If you haven't seen my Solidity tutorial. I will suggest you to visit the Solidity tutorial before watching this video. If you are, if you want to know all these things in detail, I have discussed about all these things. Now comes the part by which we are going to create a random function. Because in a lottery, we already know, right, that in a lottery, anyone can win a lottery. So there is a random kind of thing is going on, right? It is like we are randomly picking any player from this players array, right? So we need to have a random number in order to pick a random player from this players array so that we can pick him as a winner. Okay. So for that, I'm going to create one more function by the name of random. Okay. And I will make this function internal so that only we can call this function inside this contract only. And then we will have a view. Again, this will return a random number, so uint. Now, in order to generate this random number, what I am going to do is I'm going to use ABI in code packed. Okay. And this ABI in code packed will take three things, that is block.difficulty, then block.timestamp, and then players.length. Okay. So it will take three parameters, I will say. And then after this, we will take a kcac 256 hash of this particular output. And since we want a uint kind of output, again, I will typecast it to uint. Okay. And then I will simply return this value. So if you will see here, you do not need to worry about that. What I am trying to do here with this particular ABI.encode packed, that is actually out of the scope of this course. But this syntax is actually generating a random number, that is for sure. But let me warn you about something, that you should not use this random function. Definitely I'm using it because this is a beginner level project, so I'm using it. But if you want to actually have a random number in your smart contract, in that case, I will suggest you to use a Oracle. Yeah, you should use a Oracle in order to, generate a random number. Now, what are oracles? How to use that? I will definitely make a tutorial on it. If you want me to, just comment below that, okay, we want a tutorial on Oracle as well, and definitely I will make a tutorial for you on Oracle service. Okay, but for now, for demonstration purpose, I am just using this random function. And again, you should not use this random function in your real smart contract. Okay, because this is not a random function at all. It is just a, it is just like a temporary solution for generating our random number. Let me show you the output of this random number as well, so that you are sure what I'm trying to do. Let me make it public for now. Let us deploy this contract so that we can check till now what we have done, so that we do not have any confusion and we do not have any compilation error. Okay, so let me select, what is the issue here? Okay, I made a mistake in the, okay, it should be in code packed. Now it is good. Okay, let me select the latest version. Okay, why it is not selecting the latest version? Let me check, guys. Okay, for now it is showing me 0.8.7 only. This is strange. It should not do that. Okay, for now, okay, it is 0.8.7, but rest assured, you can also use it in 0.8.17 as well. I think there is some issue with Remix ID. Sometimes there is a bug, and I am not sure why it is showing right now only this particular version, 0.8.7. But it's okay. You can run this program in 0.8.17 as well. That will not be an issue. Okay, because I'm using the latest syntax and everything. So now let me deploy this contract just to test, like till now what we have done. So now let me click on this random function. Let us check. Okay, so you can clearly see that such a huge random number it is actually generating, right? Again, if I will click on random, so you can clearly see that. So this is actually generating a random number. Okay, and that's the thing. But definitely you should not use it, right? And this is the balance. Let us check this whether it is working or not. Yes, it is working. Balance of the contract currently is 0. That's why it is returning 0. And manager is this person who has actually deployed this contract, right? So this is the constructor that we have worked on, and we will actually work on the participate as well, but not now. Let's check the winner. So if you will see, currently winner is by default 0 cross 0 0 0, because winner, like we haven't initialized the winner yet, right? Okay, so till now our contract is working correctly. Let's now create our last function, which will actually help us in picking up the winner. Okay, so function pick winner, and I will make this public. So now, first of all, I will make sure that this pick winner function can only be called by the manager of our contract. So manager should be equal to message.sender. Okay, otherwise we are going to throw an error that you are not the manager. Okay, otherwise anyone will call this pick winner function whenever they want. Another thing that we want is that we want to check the restriction part, right? As we have discussed in the algorithm as well, that the players.length means the array of this particular this particular lottery means the people who are going to participate into this lottery, they must be greater than equal to 3. Otherwise, we are going to throw an error that players are less than 3. Okay, now again, I will create one more variable here, which will actually give us the random number. That is by calling the random function that we have created. And again, let me make it internal only. We do not want that it is accessible to the public. So, okay. And now I will create one more variable, because if you will see, this random number is a very huge number, right? And we do not want this huge number. What I will do is I will find the index from this random number by doing r modulo players dot length. So what this r modulo players dot length will do, it will find the remainder, right? It will find that this modulo operation is actually used to find the remainder. Let me show you. So let me do control plus shift plus j, and here if you will see, let's say I have a big number 1 2 3 4 5 6. So you will see that this modulo 3 is giving us a number 0, right? And in the same way, if I will do 4 modulo 3, I'm just taking 3. Okay, players dot length as 3 means 3 players have participated into this lottery, so but that's why 3. Otherwise you can take any other number as well. So you will see that it is 1. Let me take let's say 2 modulo 3. So it is 2, and 1 modulo 3 will be 1, right? So what this modulo operation is actually doing is, this modulo operation is actually providing us with all the numbers, if you will see 0 1 2, and these 0 1 2 are actually less than 3. So this will make sure, this expression will make sure that this modulo operator will always provide us with a number, or I will say the remainder, because 3 is actually getting divided, like 3 is dividing this particular number, and the remainder is 0 in this case, 1 in this case, 2 in this case, and 1 in this case. And this modulo operation will make sure the number that we are going to get as a remainder will always be less than this particular number, okay, from which we are actually taking the modulo. So in this case 3, so 0 1 2. Again, otherwise if we have modulo as 4, so in that case the value that we will be receiving by doing the modulo will be 0 1 2 and 3. So there will be no 4. Like, this will actually help us to find the index, right? Because we are taking this huge number, we are taking the modulo of this huge number, so we will have some number which will be the index of our array, of our players array. So for that only, from that actually only, we will find the winner. So we will do players, we will take index, and by this we have found the winner of this lottery. And once we will find the winner of this lottery, we will transfer this amount. Which amount? Actually the balance of our contract to our winner's address, right? If you will see, we have created this get balance function in order to fetch the balance, right? And this function can only be called by the manager, and this function can also be called by the manager only. So when manager will call this function, he will be able to call this get balance function as well, and whatever balance will be there in our contract will get transferred to the winner's address. That's why we have made this winner's address as a payable address. Okay, now once this is done, means once the transfer of our smart contract balance is done to the winner, okay, what we will do is we will again make the players array to 0. And how do we do that? We do that by this particular syntax that I am doing currently. This will initialize the players array back to 0, okay, so that we can restart our lottery. With this, we have completed our lottery smart contract. Let us quickly check it whether it is properly working or not. And yes, for sure, like I hope you have understood this pick winner function. We are simply finding the random number, we are taking the modulo operation on this random number, so that this huge number can be, you know, so that we, by dividing this huge number, we get these smaller numbers, and from these smaller numbers we are picking up a random index, and then we are transferring the balance, and we are making the player's length again back to 0, so that we can re-execute this lottery. Now let us check this. Let me redeploy it. Okay, so now again we have all these different functions. Let us check the manager. Winner is 0, and get balance is 0. Okay, pick winner will not work, and participate will also not work. Let us participate. So I'm selecting this address as the first participant, and he is transferring 1 ether. So now he will click on participate. So if you will see, as soon as he has participated, 1 ether is deducted from his account, and 1 ether is actually, you know, the part of this contract balance, 1 ether. In the same way, let us pick this address, and again we will transfer 1 ether. We will participate 2 ether. So it's going good. And let's do again from different address, let's say this address, and again we will participate. Okay, I have made actually some mistake. Okay, let me again select 1 here, and now I will click on participate. Okay, now it is done. So if you will see, we have 3 ethers in our contract balance, means 3 people have participated inside our lottery smart contract, right? Now what we will do is, we will check our participant by clicking on this players array. So let me check at 0th index. So it is 0AB8, right? First index 04BA2, right? And last one is, I think, 7th one, right? 0787, right? So all these 3 peoples, as we are seeing on our screen, 1 ether has been deducted from their account and they have participated into the lottery. And we require 3 people at least in order to participate in the lottery, right? And we have the 3 people. So now we can again go back to our manager address. And now what we will do is, we will simply pick the winner. And let me pick the winner. So you will see, as soon as I will click on this pick winner function, 3 ether will get deducted from my contract balance and will be transferred to a random person, like any like this 3 ether will be transferred to any of these 3 accounts. Okay, and we will check it. Like currently all of these are having around 98 ethers. So after 3 ethers will be added to their account, it will be around 101 ether, right? So now let me click on pick winner. And hooray, so this transaction is successful. Now let us check this. And this person is actually the winner, right? You can clearly see that 101 ether has been 3 ether has been transferred to this account. And we can check that here as well by clicking on the winner function, but not winner variable. So here you will see that 0AB8 is the winner of this lottery. And if you will redo it, chances are very high that this will not be the person who is actually selected for this lottery. Like definitely it is a totally random thing that is happening. So he might be the one or he might not be the one. That's my point. And this is how our lottery smart contract works. And if you will recheck the array, you will see that it is again back to 0. And that's why it is throwing us an error that there is no player exists, because we have reinitialized this array back to 0. Okay. So this is how our lottery smart contract works. I hope you have enjoyed this particular project. If you have any confusion, you can definitely comment below the video. I will happy to answer your query. Now it's time to deploy our smart contract on the test network. Now before deploying it on the test network, we need to understand what is a test network, right? So let us see the difference between main network and test network. So when I am saying main network, I am talking about the real blockchain. So when I'm saying main network, I'm talking about the Ethereum blockchain, the real Ethereum blockchain. Okay, it's the Ethereum mainnet. And when I'm saying testnet, I'm talking about a fake blockchain. Okay, it is a blockchain where you do not have to pay any kind of money. As the name simply suggests, this testnet is for testing purposes. So if you will see the use of main network, it is used for actual transactions with value. Means if you are going to deploy your smart contract, or let's say send some ether on the main network, you have to pay real money. You have to buy ether from the market, and then you have to use those ether in order to deploy your smart contract or send some ether to your friend. While if you are using test network, in that case, we can use test network for testing our smart contract. So if you are thinking to deploy your smart contract, if you want to test your smart contract, in that case, it is suitable first to check your smart contract on the test network, because it is free of cost. It is given to you for testing purposes. And then you can finally deploy your smart contract on the main network. So it is like a testing playground. When I'm talking about main network for Ethereum blockchain, main network ID is 1. And talking about test network, every test network has its own ID. You do not need to go in details of this IDs. Okay, I'm just telling you so that you are not confused whenever you see this term network ID. Okay, so like for example, we have different kind of main network and test network. Like for main network, we have only Ethereum mainnet, the real Ethereum blockchain. And when we say testnet, we have Goreli. And let's say for Goreli, it's I think the network ID of Goreli is 3 or 4. I'm not sure. We will see that. And there are other test network as well, like I think the name, I'm not able to pronounce that name. I think it's Sperolia. I'm not sure, guys. You have to check it. So there are so many different test network as well for testing of our application. So before deploying our smart contract over the mainnet, it's a good practice to deploy and check your smart contract on the test network, because your test network behaves just like your main network. The only difference is that test network does not cost you any money. It is for testing purpose. Now let me show you an example of Etherscan, which is actually our real main network, and goreli.etherscan, which is actually a network for the fake blockchain. So let me go to Etherscan first of all. So this is your Etherscan. On this Etherscan, whatever blocks you are seeing, right? All these blocks are actually real blocks. So these are the part of real blockchain. So all these transactions are actually happening on real Ethereum blockchain. And for these transactions, you need to pay some amount of fees, or I will say ether. While if we will go to our Goreli, okay, let me go to our Goreli Etherscan. So all these blocks that you are seeing on your screen, right? All these blocks are actually fake blocks. The only purpose of these fake block is to test your smart contract, is to test your transactions. So you can clearly see that there is no difference between these two pages. The only difference is that this one, this Goreli one will not cost you any money, but this one will actually cost you some amount of money. Okay. Now, in order to deploy your smart contract on a test network, you need a wallet. And for our smart contract deployment process, I'm going to use MetaMask wallet, but definitely there are other wallets as well. But I'm going to use MetaMask wallet in order to deploy our smart contract on blockchain. Now, why do we need a wallet in order to deploy our smart contract on a blockchain? The reason for this is very simple. Because whenever you are deploying your smart contract on a blockchain, you are occupying some space, right? And for that space, you need to pay some amount of money because you are occupying some amount of space on the blockchain, right? You're renting blockchain. And for that only you need these wallets. These wallets actually works as your signature. Means, let's say this is your smart contract which you want to deploy on the test network, then you are going to use this MetaMask wallet in order to sign your transaction, that stating that, okay, this is a smart contract that I am actually deploying. So I'm actually signing this transaction that, okay, I am the owner of this smart contract. And for that, we need a wallet. Okay. So if you're reading from blockchain, then you do not require a wallet. But if you are actually writing on the blockchain, then you actually require a wallet to make that transaction, because you are actually changing the part of the blockchain. You are actually occupying some space on the blockchain. So you are actually changing the blockchain, right? And for that, you need to sign your transaction. It is just like whenever you are, transferring some money to some bank account, you need to provide your account number. You need to provide your PIN, right? You cannot use somebody else's PIN or account number. In the same way, you need to have account and you need to have your PIN set up in this MetaMask wallet. And then you use this MetaMask wallet in order to sign these transactions. Okay. Now, if you want to install your MetaMask wallet, just visit this particular page, metamask.io. Simply, this page will appear and MetaMask wallet support will be there according to your browser. Like, I'm currently using Microsoft Edge. Reason is because I have already installed MetaMask on my Chrome browser. So I'm not using that. Otherwise, I have to uninstall it. And again, I have to go through the same process. So I'm using Edge browser for now. I will simply click on this download for Edge. So you will see that once I have clicked on this, I will have to click on this get button. Okay, add extension. So once it will be downloaded, we can log in into our MetaMask wallet after a sign up, definitely. And if you want to learn more about MetaMask wallet, definitely you can visit their YouTube website, YouTube channel, to know more about this MetaMask wallet. So you can see that my MetaMask wallet is installed. Okay, it is downloaded in my browser. Now I have to click on this get started button. Okay, I will click on agree, and then you will see two options. Since I'm setting up MetaMask wallet for the first time for my Edge browser, definitely in your browser as well, you are seeing the same step only. Just click on this create wallet. And now you have to type your password. So let me type my password for now, and try keep your MetaMask password confidential because it is very necessary. Otherwise, you will lose all your cryptocurrency. And just click on create. So once you will click on create, you will see this particular page. In this, you have to simply click on next for now. And then MetaMask will provide you this secret recovery phrase. Now, what is this secret recovery phrase? This is just like your private key. You can think it like your private key only. So in case you forget your password, or in case you want to log in into your MetaMask wallet, then you can use this secret recovery phrase in order to log in to your MetaMask wallet. And by mistake, if you have, disclosed this secret recovery phrase to anyone, then I will say then your MetaMask wallet is in danger. Do not do that. So in this, you can clearly see that MetaMask is actually giving us a warning. Never disclose your secret recovery phrase. Anyone with this phrase can take your Ether forever. So first thing to remember first is that do not share it, and second thing is do not forget it. Okay, so if you want to have some real cryptocurrency, then do not forget this phrase, because this will be very beneficial if in future you forget your private key or something. So just click on this. So you will see the secret recovery phrase. I'm showing you this secret recovery phrase because I'm just demonstrating you how you can use this MetaMask wallet. But in your case, if you have some real ether or cryptocurrency, do not reveal this thing. Okay, this is very, very, very crucial thing to know. Then just copy this down because we are going to use this. I will click on this next. Then I have to enter the secret recovery phrase in the same order. So let me paste my secret recovery phrase here. Online notepad. I will simply use this one. Okay, I will paste the secret recovery phrase. I will simply now go to MetaMask. Okay, so these are the options that I am seeing. So first of all, easily. Okay, so I have to just quickly select easily, then down. So I'm doing this in a fast way. Okay, you can do the same like me. So now I will click on confirm. So now congratulations, my account is created. So you can see your MetaMask account. And if you remember from our blockchain tutorial, okay, so I have uploaded a 6 hours blockchain tutorial. If you haven't seen that video, you can see that. So in that video, I have told you about the externally owned account, right? So this is our externally owned account, and we need to have Go Rally test network here, right? Currently, you can see that I have Ethereum main network, but I need Go Rally test network because I want to do deployment on our Go Rally test network, right? So what I will do is I will simply click on this add network, and then I will go to add network manually. Now inside this, I need to fill the details in order to have my Go Rally test network in this network tab. Just fill out these details as you are seeing on my screen. So just fill out these details so that you can also have this Go Rally test network. So this is your chain ID, network ID, currency symbol, and this is your blockchain explorer. Definitely it is optional. This is also like you can have any other name, whatever you want. So it will show as a cryptocurrency here. Let me show you. Okay, so Go Rally ETH, right? So whatever cryptocurrency symbol you want, you can choose. Remember to have these two things exactly the same that you're seeing on my screen. Okay, these two things should not be different. Okay, and definitely whatever networking name you want, you can have it. But okay, Go Rally test network we are using, that's why Go Rally test network is fine here. Okay, now once you will do this, you will see that you will have some accounts, or you will see that you do not have any accounts. So like currently in my case, you can see that I have some accounts, right? So in this, if you will see, let me go back to show you in a better way. You will see that I have some accounts here, right? Like this. In your case, it might be 0, or you might not be seeing any account. So in that case, you have to simply click create account if you're not seeing any account. Okay, so like me, so just create an account and just type your account name. Let's say lottery. So I'm just giving it a random name. Whatever name you want, you can give it to it. Okay, so now I have account, but in my account currently have no ether, right? But I need to have some ether so that I can deploy my smart contract, because deploying my smart contract will require some amount of ether. Now in order to deploy, in order to have some fake ethers, what I will do is I will simply go to gorallyfaucet.com. Okay, so this gorallyfaucet.com. Now once you will go to this gorallyfaucet.com, just log into Alchemy. Okay, just sign up to Alchemy. Alchemy is actually API kind of a thing. We will talk about this. Okay, don't worry about it for now. We will talk about it when we will talk about Truffle and Hard Hat. But for now, what you will do is simply sign up to Alchemy, and then once you will sign up to Alchemy, you will see this send me ETH button active. Okay, like in my case, you can clearly see that I have signed up to Alchemy. That's why I'm seeing this send me ETH button. Okay, so what I will do is I will simply select my MetaMask wallet for now. I will copy my account address. So this is my account address that I have created. I will paste that account address here. I will click on send me ETH. Now it will take some amount of time so that it can transfer some amount of fake ether in your MetaMask wallet, and you can see your transaction here. So this is the transaction that is going on. It is in pending state for now. Now once this transaction will be successful, this Go Rally faucet will provide me with this 0.2 Go Rally. Okay, and we can see that. So now if you will see, my transaction is successful and I have 0.2 Go Rally ETH in my account. And this is how you transfer ether from this faucet. So faucet is an area, like I will say, this is a place where fake ethers are available. You have to transfer fake ethers from this faucet to your MetaMask wallet. Okay, So now I have my MetaMask wallet ready with 0.2 Gorilla ETH, and now it's time to deploy our smart contract on Gorilla test network. Now in order to deploy our smart contract on Gorilla test network, first of all we need to go on this deploy button, and then from this environment tab we need to select injected provider MetaMask. Now once you will click on this, you will see that your MetaMask account will get connected to this environment, and you will see your Gorilla test network ID 5 and network and the account that you are connected with. So let me open my MetaMask wallet. So you will see that, okay, I have to click on connect. So now this account is connected to my Remix ID. Okay. Now when I will click on this deploy button, this smart contract will get deployed on our Gorilla test network. And let us see that. So let me click on deploy. So once I will click on deploy, you can see that my MetaMask account got open, and the reason is very simple, right? Because once you are deploying your smart contract on a blockchain, you need to pay some amount of ether because you're occupying some space, and you can see that we need to pay this amount of ether in order to deploy this smart contract. So I will click on this confirm button. Now we have to wait for our transaction to get confirmed, and you can see your transaction at this tab. So click on this view on ether scan. So you can clearly see that currently our transaction is pending. We need to wait for some time, and hooray. So this is our smart contract deployed on the Gorilla test network. Transaction is success, and you can clearly see that this smart contract is deployed from this account. Okay, and this is our contract address. So this is a good news. Congratulations, you deployed your first smart contract on a blockchain, and we can see the interface of our smart contract on Remix ID. So this is your interface, and we have worked on this interface, right? So now as well, you can also work your interface in this particular tab as well, but definitely it will take some time for transaction to get confirmed. Why? Because your test network waits just like your main network. And for Ethereum, it takes around 15 to 30 seconds for transaction to get confirmed. So if you are going to do any kind of operation here, it will take around 15 to 30 seconds. Okay, let me show you that. So let me do something. If I will click on get balance, you will see that it will not take any amount of time because these are all read only operations. As I said, read only things do not cost you any amount of money. It does not require any kind of authentication. So your MetaMask account will not get open. So let me show you. If I will click on winner, so definitely you can clearly see all these are read only functions, right? But let me call this function, this participate function, which is actually changing the ether balance of our contract, right? And actually changing this players array, right? So now when I will click on this, you will see that it will ask for MetaMask access. Okay, but definitely I cannot call this function as well. The reason is very simple, because during deployment I have taken 1 ether and I do not have that amount of money currently, right? Let me show you. So currently you can see that I have only this amount of ether. Currently I cannot call this. What I can do is I can change this value and redeploy my smart contract. Okay, but okay, I'm not going to do that for now. What I can do is I can just I cannot do anything actually. I need to make this change here so that I can show you the real part. Okay, so let me redeploy this smart contract. For now, what I will do is I will simply write, let's say, for example, 10 way. Okay, so this is the participation fees for our smart contract. I need to redeploy it because I cannot use the deployed smart contract, right? And why I'm doing this, so that I can show you how you can call this function when it is deployed on the test network. So I'm clicking on confirm. Let's wait for our transaction to get confirmed. So this is a lesson for you. Whenever you are testing your smart contract, and if you do not have that amount of ether that you are going to require in your smart contract, it's better to change that value or have some more ether in your wallet. So now our transaction is confirmed. Let us see the deployed smart contract. So this is the deployed smart contract address. Let me go back, and in this again we have all these functions, right? So now let me call this participate function, and you will see that as soon as I will call this participate function, our MetaMask account will get open. Okay, there is some issue. Oh, the reason is very simple, guys, because during participation I need to pay some amount of money, right? 10 way. So let me select 10 way, and now let me call this participate. So you can see that as soon as I have clicked on this participate, my MetaMask account got open. And now what I will do is I will simply click on confirm. Now let's wait, and this 10 way will get directed from our MetaMask account. Okay, let us see.
So you can clearly see, right, 10 way. So this 10 way will get detected from this particular account once this is successful. Okay. So as you can see, it is taking some time for our transaction to get confirmed. 15 to 30 seconds is the limit, and sometime it can be more. We have to wait for some time. Okay, now you can clearly see after 31 seconds, it got confirmed. We can go back. We can check the participants by clicking on this players array. And you will see that when I will click on this players array, it is not asking our MetaMask to get open because we are just reading some data from blockchain and it does not cost you anything. So here you can see that this is the address that actually participated into this lottery, and this lottery smart contract is deployed on the blockchain. So this is great. And you can see that 10 way got detected from this account. So everything is going great, right, till now. So nice. So do check it, okay, and let me know if you have any doubts, okay. And I will want one assignment for you. Like I want to give you one assignment that try all these functions on this test network. Okay, deploy your smart contract on this test network and try all these functions, and let me know in the comment section that you have tried it. If you have tried it, just comment down that I have tried. Okay.
Hi everyone, welcome back to Code Eater. From this video onwards, we are going to start our new project that is on crowdfunding. So let's start. So before starting with crowdfunding, we need to understand what is crowdfunding. So according to the definition of crowdfunding is the practice of funding a project or venture by raising money from a large number of people. So you might have seen these YouTube ads, right? That where an NGO is actually raising some money for some good cause. It can be child education, women education, or any other good cause. And there are different contributors from all over the world who are contributing to this good cause, and they are providing their money to this NGO. An NGO is then utilizing this money in order to fund for the child education or for some good cause. So this is what crowdfunding is. And when I'm taking the example of an NGO, it's not that only NGO kind of work comes under crowdfunding. It can be any kind of other work as well. Like it can be an investment related thing as well. Let's say we have these investors who wants to contribute to this big project. So all these investors will contribute small amount of money and they will provide their money to this central authority, and then this central authority will then fund this whole sum of money to this other project, right? Now the problem with this particular approach is that we are actually providing all our money to this central authority, and we do not know how this central authority is going to use our money. This NGO is saying that, okay, whatever money you are going to invest in me, I'm going to use that money, and I'm going to use this money in order for child education or for women education. But the problem here is that we do not know how our money is getting utilized by this NGO, right? So instead of going for this particular approach, this traditional approach where a central authority is having a control over all our money, what we can do is we can remove or we can replace this central authority with a smart contract. Now this smart contract will be the one which will be responsible for getting contributions from these contributors, and these contributors will then fund ethers, because we are going to create our smart contract in Solidity programming language on Ethereum blockchain. So these contributors will fund ether to this smart contract, and then this smart contract will fund ether to this good cause or whatever cause that has been submitted to this smart contract. Now by this, what we are doing is we are totally replacing this central authority from this smart contract program, where we are going to mention each and every rules, and this smart contract will be in public in nature so that everyone can see what are the rules and regulations that are governed in this smart contract. So this will be the project that we are going to create in this particular video. Now let us see an algorithm that we are going to use in order to create this crowdfunding smart contract. So first of all, let us understand the algorithm of our crowdfunding smart contract, the smart contract that we are going to create for crowdfunding. So in our algorithm, there will be three entities. First entity will be manager. Second entity will be the recipient to whom we want to send the contribution. Okay, so this will be the recipient. Then we will have contributors who will be contributing in our crowdfunding smart contract. Okay. Now let us understand the flow of this algorithm, like how this crowdfunding will actually take place. So this manager will be the responsible person who will be creating request for the recipient address. So this recipient can be
child education welfare, like child education address. It can be a child education welfare address, or it can be a women education, or any kind of recipient address can be there. And the manager will be responsible for creating a request for this particular recipient. Okay, and he will be creating this request. Now, once the request is created, this request will be transferred to the contributors, and then the contributors will contribute the amount that they want to contribute for this particular cause. Okay, this cause can be anything, as I said. It can be women education, it can be child education, or whatever this manager has created. Okay, now after this contribution will be done to the crowdfunding smart contract, there will be voting from these contributors. Like, they will vote whether they are supporting this particular request raised by the manager or not. If there will be 50% plus votes for the request, in that case, this ether that is transferred to this smart contract will be transferred to the recipient address, and in this way the request will be fulfilled. Okay, now the beauty of this particular algorithm, or the beauty of this particular flow, is that if you will see, the amount of ether is actually not within the hold of our manager, but this amount of ether is actually within the hold of our smart contract. And until or unless there are enough votes to support for a contribution, this ether cannot be transferred from the crowdfunding smart contract address to the recipient address. Okay, so now let us go to our remix ID and create this beautiful smart contract. Now, before proceeding towards our remix ID, let me show you the variables that we are going to create in our smart contract. So in this way, you will be able to better understand that what we are trying to do. So first of all, we are going to create a request type by using our struct data type. In this request structure, we are going to mention the description, the recipient address, the value that he is going to receive, the whether this particular request is completed or not, the number of voters. Okay, and we are going to store the information of the voting. Okay, in this mapping that we are going to create inside this request struct. Then we are also going to create one mapping, which is request mapping. This request mapping will consist of all the requests. So if you will see, this mapping is from uint to request type, and the request type that we have created in this particular slide, right? So we will be creating a mapping from uint to request. So this uint will be the request number, and this request will be this structure that we are going to create, so that we can have multiple requests in this particular mapping. So at 0th index, we can have a request 0, then at uint 1 means at mapping 0, we can have a request 1. So in this way, we are going to fulfill this particular mapping. Then we are also going to create one more variable by the name of contributors, and in this we are going to mention the contribution by each and every address. So if you will see, this mapping is from address to uint, and this we are going to fill the address, and the amount of contribution that they are going to do will be held inside this uint value. Okay, so now let us go to our remix ID, because now we have a clear picture of what we are going to create and what are the variables that we are going to create. So let us go to our remix ID now. So now let's start with our smart contract. I am highly excited doing this video. I hope you are also. So let's start with the variables part. Let us create some variables first of all. So the first variable, as we have seen also in the presentation, will be contributors. So uint, and then not actually uint, but from address to uint, right? Address to uint. So this will actually hold our contributors. So contributors. Then we will have address of the manager, so public manager. Okay, then we will have the minimum contribution. So we will also have a minimum contribution for our crowdfunding smart contract, so that anyone cannot contribute any amount of money, right? Let's say if someone is thinking, okay, I should only donate 0 ether, then we should not support that kind of contribution, right? So we will have a minimum contribution. Then we will also have one deadline for our crowdfunding, so that let's say if I want to collect this fund, let's say by 1 day or in 2 days, so I will provide that deadline as well. Then we will also have a target that, okay, let's say we need some money for child education, and I want, let's say, 2 ether for child education. So this will be our target. Okay, so the target value. Then we will also create one more variable by the name of raised amount. So this will actually hold the amount of value that we have hold so far. And then we will have one more variable by the name of number of contributors. So this will be number of contributors. Then we will also have a struct as well. So let me create one struct. That struct will be by the name of request. Okay. And inside this, we will have the description of this particular request, like what this request is raised for, then the address of the recipient to whom we will send the money, right? The ether actually, recipient. Then we will have the amount of value that we want to raise and whether this particular request is completed or not, and the number of voters for this particular request. And then we will have the mapping, okay, which will actually hold the address basically for the number of votes actually to have the voting information. Will voters. Okay, and now we will create one more mapping, and this mapping, as we have seen as well, will be from uint to the request. So it will hold our request, public requests. And one more variable we will be requiring will be the number of requests. So this will be the number of requests. Okay, so these will be the variables that we are going to use in our crowdfunding smart contract. I know there are so many different variables, but don't worry, they are very easy when it comes to the logic part. Okay, so now let us create a constructor. Now inside this constructor, we will ask for the target as well as for the deadline. Okay, and then when the target is given, we will set the target, right? We have actually created this target variable, right? If you remember this one. So we will set the target and then we will also set the deadline. Now, in order to set the deadline, I'm going to use block.timestamp. Okay, I hope you have watched my Solidity tutorial. I have explained about this block.timestamp there. And then I will have the deadline. So what I mean to say here is that as soon as this particular block is created, that will be the block.timestamp. And then we will have the deadline. So let's say if the block.timestamp is, for example, at this point of time is 500. Okay, let's say 500 second, and then we will have the deadline into it. So let's say if I want to add some 60 seconds, so now the deadline for this particular request will be 560 second. Definitely it is very low. I'm just trying to explain you what we are trying to do here. Okay, so block.timestamp will hold the current block time, and then we will add the deadline into this particular. Then we will have the minimum contribution, and let's say the minimum contribution is 100 way. Definitely it's totally up to you. If you think, okay, I do not want a minimum contribution of 100 way, I just want a minimum contribution of 10 way, you can go for that as well. Okay, and then we will set the manager by having this like this. Okay, I think there is some issue. Okay, it should be deadline. Now it's good. Now let us create one function so that we can create a request. So create a request, and inside this we will pass string called data description. Okay, then the address of the recipient. Recipient, I hope I'm having the correct spelling of recipient, and the value. Let me make this public, and what we can do is we can make sure that this request is created only by the manager. So what we can do is we can create a modifier. Okay, modifier only manager. Okay, I think spelling is wrong here. Should be modifier only manager, and inside this we will have a require statement where we will check whether message.sender is equal to manager. Otherwise we are going to send you are not the manager. Okay, and then we will close this, and we will copy this from here and we will paste it here so that this particular request function can only be called by the manager of our smart contract. And now I will create a pointer by of request type storage new request. I'm going to point to the request. So the first request means this number of requests that we have created, it will be initially 0, right? So num requests, and by this I will be pointing towards the first index of our mapping, right? Because if you will see we have this request variable, and this is a mapping. So we are pointing to the first index of our mapping. When I'm saying first index, what I mean to say is this num request will be 0. So I'm pointing towards request 0. And I have explained all these things about the storage and everything in the Solidity tutorial. So if you haven't watched that, please do watch that particular tutorial so that you can better understand this concept. And now what we will do, we will increase the num request so that for the next request, the num request is increased. Okay. And now we will take this new request and we will add the description. This, we will add the recipient address. Recipient is equal to recipient. We will have the new request dot value equal to value, and new request dot completed will be false, and new request dot number of voters will be 0 initially, right? And if you are not able to understand this particular part, don't worry, I am explaining you with the help of our presentation. So we have seen how we have created this particular mapping, right? Now what I am trying to do here is I'm trying to create a new request variable, and since I'm using this storage keyword, this new request will be acting as a pointer to this particular structure. So when we did this, what actually happened in the memory of Solidity, a new variable by the name of new request is created, and this new request started pointing towards this particular structure. Okay, since num request, we are assuming num request is 0 initially, not actually assuming because we are not initializing it with anything, so it will be 0. And that's why this new request will start pointing towards this particular structure. And when we are doing new request, right, new request dot description like this, new request dot description, right, like this, we are actually pointing towards this part. Okay, so new request dot description will point toward this, new request dot recipient will point towards this, new request dot value will point towards this. And I've explained all these things in the Solidity tutorial, so that's why I'm not giving a lot of time on this, but these fundamentals, so I will assume you have watched those tutorial before watching this particular project. Okay, now once the request is created, we can create one more function by the name of contribution. Okay, we will make this public and we will make this payable so that this particular function can help this smart contract to receive ether. First of all, we will check whether the block dot timestamp is less than the deadline, right? So that deadline has not passed for this contribution. So let's say as a manager, I have created a request for a child education program, and contributors need to contribute within 2 days. So that's what I'm checking here, whether the block dot timestamp means the current block timestamp is less than the deadline or not. Because if it is greater than the deadline, means this particular function, means this particular thing, this particular block dot timestamp actually has passed the deadline. Okay, which we do not want. So we will throw an error that deadline has passed. Okay, then we will have message.value where we will check the amount of contribution done is greater than or equal to the minimum contribution or not. Otherwise, we will throw an error that minimum contribution required is 100 weight. Okay, and then we will have an if statement where we will check whether the contributors dot, not actually dot, message dot sender is equal to 0. If this is equal to 0, then we will increase the number of contributors. So it's like we are checking whether do we have any contributors inside our contributors mapping. If this contributors mapping is empty, means if the contributor, like if the person who is actually contributing, right, who is contributing for the first time, so when the person will be contributing for the first time, in that case contributor message dot sender will be equal to 0. So that's why we are making an increase when we have this kind of condition. Okay, and then what we will do is we will simply contributors message dot sender and we will increase the amount message dot. Okay, and then we will raise the amount by the message dot value, so the amount that is sent by the sender. Okay. And we are doing this only for the, okay, just to clarify this as well, like why I'm using this. So that let's say if the same contributor is trying to contribute again, let's say I have contributed for the first time 10 ether, and in the next time I want to contribute again. So in that case, it will not be zero, right? So in the first contribution only, it must have increased to 10 ether. And let's say if I'm trying to contribute again, I do not want to increase the number of contributors in that case, because the number of contributors is the same. Only the amount the same contributor wants to spend has increased, right? Earlier it was 10 ether and now he wants to increase it to 20 ether, let's say. So that's why we have this if condition here. Okay. Now we can also create a function to check the balance of our smart contract balance, and we will make this public view returns and then uint, and we will simply return address this dot balance. Okay, what we can do is we can create one more function by the name of refund, which will actually give refund to the contributors back when certain conditions are not met. And those conditions can be, let's say, require block.timestamp is greater than deadline and raised amount is less than the target. So what I mean to say here is that if the deadline has already passed and the manager is not able to request or was able to reach the target, okay, so if the manager is not able to reach the target and the deadline has passed, in that case we can give an option to these contributors that okay, you can ask for refund, but this will be only given back if these two conditions are met, right? Whether the black means when block.timestamp is greater than deadline and raised amount is less than the target. Okay, so on these two conditions we can refund the money. Otherwise we will say that you are not eligible for refund. Okay, so that the money donated by the contributors is not wasted. So let's say if the target was 100 ether and manager was able to raise only 10 ether, so the 10 ether that were actually being invested by these contributors should be refunded back, right? Why we will be holding those money? Because we are not going to use it in any way, right? Because the target was 100 and we were able to raise only 10 ether. So we can give them an option for refund. Definitely it's their choice. If they want their refund, they can ask for the refund as well, and it's a good functionality, I think. Then we can check the person who is actually calling for this refund must have some amount of ether, right? Means he must have invested some amount of money, so it should be greater than 0. Otherwise we will say that you are not a contributor. Then we will do one thing. What we can do is we can transfer back the money to the contributor. So the person who has actually called this particular this particular function refund, we will take this, we will transfer the contribution that he has done, contributors message dot sender. Okay, so we are paying him back, and we will make the contributors message dot sender again back to 0, right? Because this person has been refunded, right? We have refunded his money, so why to have contribution then? We will make this particular part 0, and then we can create now our function for the vote request, and inside this we will pass the request number and we will have this public. Now in order to vote for a particular request, so now we have created all the functions, right, for the request creation, for the contribution, and now what we are trying to do here is we are trying to create a function with the help of which contributors can vote for a particular request. So that request can be anything, and we are now giving this facility to the contributors. So first of all, we will check whether the person who is actually calling this function is actually a contributor or not. So we will check whether message.sender is greater than 0 or not. If it is greater than 0, then it's good. Otherwise, we will throw an error that you are not a contributor. Okay. And now again, I will create that particular storage type. Actually, we will create this request variable using this storage keyword, and we will have the request inside this. So request number. We are doing this just to make the process easy, right? Otherwise I have to use this particular part again and again. By having this particular single variable, it's much easy and much clearer to understand what we are actually trying to do here, right? Now we will create one require statement to check this request dot voters message dot sender should be false. So if you remember, we have created this mapping inside this request, right? This voters. So what we are trying to do is we are trying to check whether the person who is actually voting for this request has voted for this particular request or not, has already voted for this particular request or not. So if it is true, in that case, it definitely he has voted for it. And initially it will be false if the person is if the person is first time voting for a request. So in that case, it will be false. Otherwise, we will throw an error that you have already voted. Already voted. And then we will make this request dot voters message dot sender equal to true. So this will make sure that okay, this particular message dot sender has voted for this particular request, and then we will increase the request dot number of voters plus plus. Okay, so by this we are actually increasing the number of vote for a particular request number. Okay, so this will increase that, and this will make sure that only a vote is done, like a person can vote only one time only. So one person, one vote. So this will actually make sure, this line will actually make sure that, and then we will make this true. If this is false, means if this condition is true, then we are going for this and then this. Okay, so this will for the vote request. And now let us create our last function, which is for the payment part, because we have seen, right, once the voting request is done, the manager can pay to the contributors. Definitely the contribution will be done from the smart contract balance only, but manager will be the one who will be doing this payment, because we are making manager responsible for this crowdfunding smart contract. So I will create one more function by the name of make payment, and in this I will pass the request number for which I am doing this payment, and it will be only called by the manager. So first of all, we will check the raised amount, whether the raised amount is greater than the target or not. Okay, otherwise we can throw an error that the target is not reached, okay, something like this. And then we can again create this variable storage, this request is equal to request number, this, and then we will check for this request is already completed or not by going to the completed variable, should be false. So we have this completed variable right inside the request, which is actually checking whether the request is already completed or not. So if this is condition is false, then we are going to throw an error that the request has been completed. Okay, and then we will again do one more checking for this request dot number of voters. This should be greater than the number of contributors by 2. So this is like we are actually checking whether the number of votes given to this particular request number is greater than 50% of the contributors or not. So number of contributors are, let's say, 10. So 10 divided by 2 will be 5. So we are checking whether at least 6 people have voted for this particular request or not. Okay, so that's what we are trying to do. We are actually checking for the 50% majority. Otherwise, we will throw an error that majority does not support the request. Okay, and then once this is done, we will again take the request, this request dot recipient. Okay, so this will actually give the recipient address, and we will transfer the money, this request dot value, to the recipient address. And once this is done, we will make this request completed is equal to. So by this, we are actually doing the payment to the recipient address, and then we are making this request true. But we are doing this only when the contribution, means when the number of votes are in the support for this particular request. Otherwise, this thing will not happen. Otherwise, this thing will not happen. Okay, so now our smart contract is ready. Now it's time to check this smart contract, whether this smart contract is working in a correct way or not. So now let us go and deploy this. So, okay. Now for the deployment, I need to tell the target. So let's say the target is, for example, 10. Okay, or let's set it 200. Okay, let's set it 200. And let's say the deadline is 1 hour. So I'm sending 3600 because 60 into 60 is actually 1 hour, right? So I'm converting 1 hour into 60 minutes and 60 minutes to seconds, that is 60. So I'm doing transact. Okay, so now we have all these different variables. Okay, so let us first do some contribution, or okay, means let's do some contribution by calling this contribution. So this is the manager 05B3 and we can check that. Let me show you. So this is the manager. Now let me take this address 0AB8 and let me do a contribution of 100 way. Okay, this is the minimum contribution. So I'm doing contribution. So you can see that it has increased. The smart contract balance has increased to 100 way. And let me have this particular address. Let's say he's doing a contribution of 1 ether. So 1 ether and again contribution. And let me have this last address. And let's say he's contributing 2 ether. So contribution. So in total, if you will see, we have three ether plus 100 way, right? 3 ether and 3.000100001 ether, right? Okay, so they have contributed, and now it's time to create a request. And this request, if you can see, it can be only created by the manager, right? So we need to select the manager. We need to go to the create request section. Let's say the money is for child education, and the recipient address is, let's say, this address. Okay, so this is a random address that I'm selecting, and let's say the contribution that he's needing is of, let's say, 1000 way. Okay, so 1000 way contribution he's needing. And now what we can do is we can again go back to the manager. We can do the transaction. So this is successful, and now we can check the request. So 0th request. So you can see this is the first request, right? Means at 0th index. In the same way, let's create one more request. Let's say this is for women education, and let me have some different address. Let's say this address. Let me copy this as a recipient, and instead of 1000, let me have 10,000, and let me do this transaction. Let me again select the manager, and now let me do the transaction. Okay, so now if you will check at request 1, so we have this second recipient address, and this is the amount. So currently it is not completed request, and the number of votes are 0. Okay, this is good. Now what we can do is we can check our vote request function, right? Let's see whether the vote request function is working or not. So as we have seen that these three people have contributed, right? 0AB8, 04B2 and 787. And let's select 0AB8 and let's vote for request 0. So I am doing a vote for request 0, vote request. So this vote is successful. We can check whether the vote has been done or not, going to the request. So you can see the number of votes is increased by 1, okay, because this person has voted for request number 0. And not only that, we can also check the contribution that this person has done. Let me copy this. We can go to this part and we can click on contribute. So you can say that this person has contributed 100 way as a contribution. Okay, and now what we can do is we can select some other address and we can again do a vote for, let's say, 0 request only. So I'm doing a vote for 0 request. Let me check whether the number of requests has been, means the number of votes has been increased or not, and you can see that the number of votes has been increased to 2. Now what we can do is we can go for make payment. Why? Because if you will see, the number of people, the number of contributors are 3, right? And total number of votes, total number of votes is 2, right? And if you will check whether 2, if you will check actually 2 is greater than 3 by 2, right? If you can clearly see that 3 by 2 is 1.5, and in Solidity we do not have a constant of float, so it will be 1, and 2 is greater than 1, right? So that's why this will be done, and the payment will be done to the request, this particular request recipient address. And this person has requested, means this address has requested for 1000 way, right? Now let's check whether it is working or not. So what we can do is we can go to the manager address once more, and you can clearly see whether the raised amount is greater than the target or not. So if you will check whether the raised amount, let me check the raised amount. Okay, so this is the raised amount, and let me check the target. So you can clearly see that the target was very less, right? And the raised amount is very much high. So we have good amount of money in our bucket for the contribution for making this payment. And then we can check whether the request is completed or not. No, it is not completed, it is still false, and we have to then check for this, and we have checked, right? 3 is greater than 1, so it will be fulfilled as well, and this will be done. So let's now do the payment. So I'm again back to the manager. Let me check the recipient balance. So it is 100 ether, and after the payment it will be increased by 100 way. So now I'm going to do this. I'm going to do the payment where it is. Okay, so I'm doing payment for request number 0. I'm doing make payment, and this transaction is successful. You will see that some amount of ether has been deducted from our balance, from our target, from our request total target, actually the amount that we have raised, actually, right? Because we were raising it this amount, right, by the contribution. And if you will go to the recipient address, you will see the recipient address has increased from 100 way. Okay, so hooray, our smart contract is perfectly working fine. But let us check for the request number 1. Let's say manager was thinking that, okay, why not to check for request number 1. Okay, so he tries to do a payment for request number 1 as well. So when he will do that, you will see it will not work. So make payment, and the transaction failed. Let's see what's the error. So the majority does not support the request, because this thing got failed because there were no votes for this request number 1. So this thing got failed because number of votes for a particular request number 1 is 1, and number of contributors are 1.5. So definitely it got failed, and that's why the payment was not made to the request number 1. This payment will be only made when number of contributors will be greater than 50%. And this is good. And we can also check for the refund, but I think let me give you this assignment. I want to give you this assignment. You have to check for this refund function, and you have to let me know in the comment section whether this refund function is working or not. Okay, so this is your assignment for this particular project. I hope you enjoyed this video. Meet you soon in the next video. Hi. Now in this video, we are going to see how we can create an event organization smart contract project. Now our event organization smart contract project will consist of 3 entities. First one will be the organizer, who will be organizing an event, and then we will have attendee who will be attending the event. Now in order to attend this event, attendee need to buy some tickets, and attendee will also be having this facility of transferring the tickets that he has brought to any other address. So let's now go to our Remix ID and code this event organization smart contract. So now let us start with our event contract. So first of all, we will create one struct, okay, by the name of event. And in this struct will have the address of the organizer, the person who will be organizing this particular event, then the name of the event, date of this event, price of this event, and ticket count. Okay, and then we will have the number of tickets that are remaining. Okay, so ticket remaining. Okay, now after this we will create one mapping, and this mapping will be from uint to event struct that we have created. Now this mapping will actually have the details of all the event that are being created. So it will contain the details of all the events that are being created. We will again create one more nested mapping. Okay, so this time we will create a nested mapping, address to mapping, and this will be from uint to uint, and then we will make this public tickets. Okay, now this will actually have the information regarding the tickets of an event, and which you will understand once we will start coding our smart contract. So just don't worry about it. And now we will have one more variable by the name of public next id. Okay, now we will create one function which will actually help us in creating an event. So create event, and inside this we will have called data, name of the event, then okay, not actually date will be in uint, so date of an event, price of an event, and then we will have the ticket count, and we will make this public. Okay, now in order to create an event, first of all we will check that the block.timestamp is, I will say the block.timestamp is less than date or not. Means we are actually making sure that whatever date that we are going to pass inside this create event, we will make sure that this date should be greater than the block.timestamp, because if it is not greater than the block.timestamp means the event has already ended. So we will throw an error that you cannot create an event for past date. Okay, means the date that has already been passed, you cannot create an event for that particular date. Then we will also check for the ticket count, that ticket count should be greater than 0. Otherwise we will throw an error that ticket count must be greater than 0. And it makes sense also, right, that there should be an event cannot have 0 tickets, otherwise who will attend that particular event, right? And then what we will do is we will use our events mapping, and inside this we will have the next ID, and then we will simply insert the event details. So event message.sender, the person who will be calling this particular function will be the organizer, so we will take message.sender. Okay, and then we will have the name of the event, date of the event, and in this date we will add the block.timestamp. Okay, or no, we cannot do that, right, because we are actually passing this date like this, so we cannot do that. Let me remove this. We need to pass the total time in this date field, right? So yeah, and then we will have the price of the event, and then ticket count, and then the ticket remaining, and the ticket remaining and ticket count will be the same, so I can have ticket count here. Okay, so what I mean to say here is that during the creation of an event, the number of remaining ticket and the number of total tickets will be the same, right? Because no one has actually brought the event ticket, so the total count of the remaining ticket will also be equal to the total number of tickets. So that's why I'm providing ticket count in the starting. And then what we will do is we will increase the ID, so that for the next event we have a different unique, or I will say a unique ID, right? And after this we will create one more function by the name of buy ticket, and in this we will mention the ID of the ticket, means ID of an event, and then we will mention the quantity of the quantity of the ticket that we want to brought for this particular event. We will make this public, and since it is something related to the buying, we will have the payable function, so that anyone who wants to buy the ticket then directly send money to the smart contract. First of all, we will check whether events id dot date is not equal to 0, because it will mean that event does not exist. Event does not exist, because initially if you will see, when there will be an event created, right, or when there will be no event created for a particular ID, in that case initially the date field will be 0, because we are using struct, and initially all the fields of the struct will be according to their data type, and in the date, since the date is of uint data type, so initially it will be 0 if there are no events. So that's what we are checking for. So if events id dot date is not equal to 0, then we are going to the next line, otherwise we are going to throw an error that event does not exist. Let me show you this with the help of an example. So this is our event, right? This is our event, admin, name, date, price, ticket count, and ticket remaining. Now once we have created this events mapping, what we have in the Solidity background, or I will say in the background, what is actually going on is that we have a mapping like this, right? Okay, this is the mapping for the events, right? Let me go back. Okay, it's good. So once we will do this, we will have a mapping like this, and this mapping will consist of uint as the key and event as the value. And this uint will be of 0, 1. This will be the next IDs, right, that we are actually having inside our mapping. So events next ID, and then this events next ID will be pointing towards a event, right? So when we are saying that events 0 or when we are saying events 1, we are actually pointing towards these events. And when we are saying that events 0 dot date, what we are trying to say here is that event 0, which is actually pointing towards this, we have to fetch the date of this particular event, that is this thing. And if we are saying that events 1 dot date, we are actually fetching this particular thing. And initially what I'm trying to say here is that initially this date field, this name field will be according to their data type, because if there are no events, in that case, the structure will consist of the initial value of the data types, right? So name will be empty, date will be 0, price will be 0 because these are uint type and this is a struct type, string type. So accordingly, we will have the initial value. So here also, when we are doing this events id dot date not equal to 0, we are actually making sure that there must exist some event for the ticket to buy for. Okay, then we will again check events id dot date should be greater than the block dot timestamp. Means the event has not ended. Event, otherwise we will throw an error that event has ended. Okay, and then we will create an event type variable storage, and it will be an event type variable. This will actually help us in pointing towards our mapping. So events id. So now this event variable will start pointing towards this particular field, and this particular field will actually consist of this struct, right? Because this is a mapping, and we have seen that this mapping is actually pointing towards an struct, right? Because this is from uint to an event type. And now we will again do a required statement where we will check whether the message.value, means the amount that is paid by the buyer, is equal to the events dot price into quantity. Otherwise, we will throw an error that ether is not enough. So what we are trying to do here is that we are checking what is the price of one ticket, and then we are multiplying it with the quantity, the number of tickets that this person wants to buy. And if this amount and these amounts are equal, then only we are going to pass. Otherwise, we will throw an error. Okay, we have some issue here. Let me check. Okay, I think it is event. Okay, yeah, now it is good. And once we will pass this condition, we will check for other thing, that is event dot ticket remaining should be greater than equal to the quantity, right? Because if the number of tickets remaining for a particular event are less, in that case we will not be able to buy tickets, right? So we will throw an error that not enough tickets left. Okay, and then we will again have our event dot ticket remaining minus the quantity. So if this condition also pass, then we are going to subtract from the remaining tickets the quantity that has been brought for, and then we will enter this information in the tickets nested mapping. So message.sender, and for this particular ID we will increase the number of quantity. So what we are actually doing here is we are simply using the nested mapping. Let me show you this with the help of an example. Since we have constructed this nested mapping, and I have told you in my Solidity tutorial that whenever there is a nested mapping, just imagine that nested mapping as a 2D array, right? So here also I'm imagining this nested mapping as a 2D array, which will look something like this. So on the left hand side, we will have the addresses, this particular thing. So address 1, address 2, and address 3. And for this uint and uint, we will have this uint in the starting, means this will be the id part. Okay, id1, id2, and so on. I'm just demonstrating a 2x3 2D array, but definitely it can be a 3x3 or whatever you want to think of, right? You have to just imagine it as a 2D array. And inside this, we will have the number of tickets. So let's say if address 1 is buying a ticket for id 1. So
tickets, address 1, ID 1. So we will fill that information inside this particular box. And in the same way, let's say some address 3 wants to buy a ticket for ID 2. So for an event that is whose ID is 2, so we will fill that information inside this particular mapping. And why we have created this nested mapping? We have created this nested mapping because a particular address or a single address can brought tickets for many events, right? It is not mandatory that a particular address will buy ticket for a single event only. So he can buy tickets for many events. So that's why address 1 in this case, as you can see, can buy ticket for ID 1 as well as for ID 2. In the same way, address 2 can buy ticket for ID 1 and ID 2, and address 3 can also buy tickets for ID 1 and ID 2. Okay, but definitely it can be more than there can be more than one IDs, right? There can be more than two events. So there can be ID 3, ID 4 and ID 5, but we are not mentioning here because it will just increase the length of this array. But I hope you understood this concept, because I have discussed the same concept in the nested mapping part also of the Solidity. And if you still are not able to get this particular concept, I will advise you to watch the nested mapping video that I have created in the Solidity tutorial. Okay, so now by this, we are actually saying that message.sender means the person who has actually called this particular function is buying ticket for this particular ID. And this is the total number of quantity of tickets that he has brought for. Now we will again create one more function by the name of transfer ticket, with the help of which we can transfer ticket. So we will have to mention the event ID, means the ticket for which we have brought the ticket for, the quantity, and the address of the person to whom we want to transfer this ticket. And we will again make this public or external, whatever you think, right? You can mention that. Now again, we will check for these two things. So let me copy these down. Okay. And now we will again, now what we will do, we will check for the tickets part. So the person who is actually transferring the tickets, we need to check whether he has enough amount of tickets or not. So it should be greater than the quantity. Otherwise, we will throw an error that you do not have enough tickets to transfer. Okay. And if this is true, in that case, we will decrease the amount of tickets from the message.sender value. So minus quantity. And we will increase the number of tickets for the to address, and ID, we will increase it to the quantity that has been transferred. Okay, now by this we will be able to transfer ticket to some other address as well. Now it's time to check our smart contract, whether our smart contract is working in a correct way or not. So let me go and let me deploy this. Okay, so this is our smart contract, and let us create an event. So to create an event, I need to mention the date as well, right? So let me go to Unix timestamp, Unix epoch time. This will actually provide us with the timestamp. So currently, if you will see, the timestamp is this, right? So what we will do is we will have this value. Okay, and let me increase this value to, let's say, by 1000 seconds. Okay, so by increasing it to 1000 seconds, it will be, or by what I can do is I can increase it to 3600 seconds. So what I'm trying to do here is I'm trying to make sure that this particular smart contract is active, or this particular event, not actually smart contract, this particular event is active for 1 hour. Okay, so that's why this value and this value addition. And then we will have the description of an event, and it can be, let's say, movie. Okay, and the price is, let's say, 10 way, and the ticket count is, let's say, 100. So now I'm creating this event. This address is creating this event. So transact. Okay, I think I made some mistake. Let me check. What is the issue here? Let me check the issue. I think the issue is with this. I made some mistake here, I think. So let me do one thing. Just let me, I know this will not give a correct value, but this will actually give us an estimated value. We can improve the logic as well, so don't worry. But for now, let me have this only. Okay, now let me do transact. Okay, now this is successful. Now we can check for the event. Let me check event 0. So this is the organizer. This is the ticket count. This is the total ticket remaining. And this is the price.
and this is the date. Okay, so this is the time of the event. Now what we will do is we will buy one ticket. So let's say this AB8 wants to buy some ticket. So he will go for the buy ticket option. He will mention the ID. So 0, 0. And let's say he wants to buy 10 tickets. So 1, 0. Now, since the cost of one ticket, if you will see, is 10 Wei, right? So he need to provide a price of 100 Wei, right? So that he can buy 10 tickets. So one quantity is 10 Wei. So one ticket cost, if you will see, one ticket cost 10 Wei, right? So 10 Wei, the price of one ticket, and he wants to buy 10 tickets. So he need to pay 10 into 10, right? So he will mention 100 Wei here, 100 Wei, and he will do transact. Let me check the address. Yes, transact. So this is successful. So now if we will go and check for the remaining tickets, you will see now this particular address has only, like, not this particular address, this, the number of remaining tickets is 90, right? Because 10 tickets has been brought down by this particular address, this one. Okay, now let us check whether this address has some tickets or not. So for that, we will go to our transfer ticket, not actually transfer ticket, but to our tickets part, this nested mapping. We will mention the address. Let me mention the address and the ID of the event, which is 0, right? So when we will check, you will see that he has brought, this particular address has brought of ID 0, 10 tickets. Okay. And let's say we want to check whether the transfer ticket function is working or not. So let's check that as well. Let me select this address. Okay. And let's say this AB8 wants to transfer 5 tickets to this particular address, that is 04B2. So let me do that. Let me mention the ID 0, the quantity 5, let's say, and the address is this. Now let me do transact. So this is successful. Now if you will check the number of tickets which are left by this particular address, you can clearly see it is 5. And now we can have the address to whom this particular AB8 has transferred the tickets, right? Let us check whether he has received 5 tickets or not. Call, and now it is also having 5 tickets. So with this, we have completed our smart contract where we have seen how to create an event, how to buy ticket for an event, and how to transfer ticket to some other address using the transfer ticket function that we have created inside our event organization smart contract. So I hope you enjoyed this video. Meet you soon in the next video.